Welcome to the Huberman Lab podcast, where we discuss science and science-based tools for everyday life. I'm Andrew Huberman, and I'm a professor of neurobiology and ophthalmology at Stanford School of Medicine. My guest today is Dr. Chris Palmer. Dr. Chris Palmer is a psychiatrist and researcher at Harvard University. He focuses on how metabolic health and mitochondrial health in particular can be leveraged to treat and in some cases cure psychiatric disorders including schizophrenia, autism, depression, bipolar, and ADHD. Today we discuss how metabolic health, something we hear a lot about nowadays, is really about mitochondrial health and the specific lifestyle and other factors that you can use to improve mitochondrial number and function. We talk about things like exercise, sleep, sunlight, which you've heard about before, but we talk about those from a different perspective, and we discuss some things that have never been discussed before on this podcast, at least in light of mitochondrial health, things such as creatine, methylene blue, nicotine, and we talk about the key role of specific B vitamins and iron in brain function. We also have a very direct discussion about vaccines and whether or not inflammation caused by vaccines can potentially damage mitochondria, which then leads to mental health challenges. And of course, in that context, we discuss the vaccine autism debate. We also discuss public health and what is needed to truly change the way people exercise and eat, and the rapidly changing landscape of the National Institutes of Health and the CDC. As you'll soon hear, Dr. Palmer gives us a masterclass on mitochondrial function and how to improve this vital aspect of our health. If you've heard about metabolic health, you've heard about the obesity crisis, that's important. But looking at all of that and approaching it through the lens of mitochondrial health, you'll soon learn, is absolutely the way to go. It's a new perspective that will change the way that you think about mental and physical health, and that no doubt will impact your health practices in very positive ways. Before we begin, I'd like to emphasize that this podcast is separate from my teaching and research roles at Stanford. It is, however, part of my desire and effort to bring zero-cost-to-consumer information about science and science-related tools to the general public. In keeping with that theme, this episode does include sponsors. And now for my discussion with Dr. Chris Palmer. Dr. Chris Palmer, welcome back.
Thank you so much for having me back.
I credit you with leading the call to arms, the public awareness, and the implementation of what some people call metabolic psychiatry, but what we could easily just call the relationship between mental and physical health, and the use of nutrition, supplementation, and, where appropriate, prescription drugs for the treatment of mental health. But what do you call this field that you've basically founded and that you're pioneering? There are others, right? But that you're pioneering, and how should the general public think about the relationship between mitochondria and their mental health? For those that are not aware, educate us.
I could talk for hours on this. So first of all, thank you for, I think you're actually giving me way too much credit though.
I don't know about that.
I'm talking a lot about it, and I think I will accept that maybe I'm able to talk about it in a way that helps people understand it, that other scientists haven't been able to. But, one of the more important reasons I want to say this is because, unbeknownst to a lot of people, this field has actually been around for about a century and a half. Researchers in the 1800s, around the turn of the century, well up into the 1960s, were hyper-focused on the role of metabolism in severe mental illness, schizophrenia, bipolar disorder. They were actually measuring levels of lactate and glucose and other kind of metabolic biomarkers in people with schizophrenia and bipolar disorder, documenting differences, really kind of honing in on these metabolic disruptions as potentially the cause of mental illness. And then our field lost its way. We became focused on neurotransmitters and assumed that they were the primary cause of mental illness, while other fields were focused on psychological and social factors. We got cognitive behavioral therapy. We still had psychodynamic psychotherapy, but people were doing research on adverse childhood experiences. That was really taking off, documenting that that's related. And so, the field kind of splintered into these biological, psychological, social camps. And people really hyper-focused in all of these ways. To me, this field of integrating metabolism with mental health, with physical health, is about unifying that whole story. It's about unifying and building on what these researchers 100 years ago were pursuing. It's about integrating the biological, psychological, and social camps. It's about putting it all together and stop being so reductionistic and simplistic to suggest that it's all biological or it's all psychological or it's all social, and that if it's one, it can't be the other. It can be all of them. And it's different combinations for different people. So in many ways, I'm just standing on the shoulders of giants who have done groundbreaking work to create the science that allows us to put this all together. With that said, I do firmly believe that we are on the cusp of a revolutionary change in the paradigm of the mental health field, of how we think about mental illness. You know, there are myriad biological things. The psychological and social things are all obvious and true. Yes, stress, trauma, loneliness, adverse childhood experiences, all of those things come together. Our field has long known that all of those things play a role in mental illness. Exactly which mental illnesses? It's essentially all of them. Every one of the labels in DSM-5 can be impacted by biological, psychological, and social factors. So trauma in childhood increases risk for post-traumatic stress disorder. Duh, everybody knows that. Trauma in childhood also increases risk for neurodevelopmental disorders if it occurs early enough. It increases risk for substance use disorders, personality disorders, psychotic disorders, mood disorders, anxiety disorders, dementia later in life, and everything else, every label. What else do adverse childhood experiences increase risk for? All of the metabolic disorders, obesity, type 2 diabetes, cardiovascular disease, autoimmune disorders, premature mortality. You know, we have statistics that, just sticking with that theme, adverse childhood experiences. If you have 6 or more adverse childhood experiences, compared to somebody who has no adverse childhood experiences, now that's a rare group, granted. But for the people who have 6 or more, on average, they live 20 years shorter. They lose 20 years of life because of those adverse childhood experiences. And so is that a mental health issue? I would say it's a physical health issue. It's both. It's both a mental health issue and a physical health issue. And so how can we understand that? How can we understand that trauma in childhood increases risk for heart disease and obesity and diabetes and dementia and PTSD and ADHD and substance use disorders? And the only way to connect it is through metabolism and ultimately through mitochondria. Unfortunately, people like simple answers, and they're like, so diet will fix everything. I'm like, no, I never said diet will fix everything.
But it can help.
It can help, and it can be life-changing and life-saving. I don't want to minimize or step back from my work with dietary interventions. There is no doubt in my mind it can dramatically change people's lives. Mm-hmm. But it's not just diet. It's lots of other things. And so it's putting it together and trying to make sense of the science for what does cardiovascular disease have to do with depression or PTSD. On the surface, a lot of people scratch their heads and they really don't know. They assume that, well, one's a brain disorder and one's a heart disorder. And it's like, no, we need to integrate that because all of the risk factors, this essentially the same biopsychosocial risk factors that increase risk for heart disease also increase risk for brain disease. And we need to start putting it together. We need to be more sophisticated. We have computers. We have AI. It's 2025. We can do better.
Yes. Well, first of all, and I'm sure the listeners really appreciate your humility regarding who's responsible for the big surge in the interest in this field. So thanks for crediting your predecessors and the others in the field. At the same time, I credit you with really popularizing a lot of these terms, being willing to go public facing and share about metabolic psychiatry, for lack of a better way to put it, metabolic psychiatry, and really championing these ideas and being open to being part of a medical and science and public discourse community. So I'd be remiss if I didn't say that. So hopefully you'll take that in, and if you won't, then
I very much appreciate it.
Right.
And
Well,
thank
it's
you.
true.
Thank you very much.
It's true, and I'm not alone in that sentiment. I'd like to take a quick break and acknowledge our sponsor, Our Place. Our Place makes my favorite pots, pans, and other cookware. Surprisingly, toxic compounds such as PFASs or forever chemicals are still found in 80% of nonstick pans, as well as utensils, appliances, and countless other kitchen products. As I've discussed on this podcast, these PFASs or forever chemicals like Teflon have been linked to major health issues such as hormone disruption, gut microbiome disruption, fertility issues, and many other health concerns. So it's really important to avoid them. This is why I'm a huge fan of Our Place. Our Place products are made with the highest quality materials and are all PFAS and toxin-free. I particularly love their Titanium Always Pan Pro. It's the first nonstick pan made with zero chemicals and zero coating. Instead, it's pure titanium. This means it has no harmful forever chemicals and that it doesn't degrade or lose its nonstick effect over time. It's also beautiful to look at. I cook eggs in my Titanium Always Pan Pro almost every morning. The design allows for the eggs to cook perfectly and without sticking to the pan. I also cook burgers and steaks in it, and it puts a really nice sear on the meat. But again, nothing sticks to it, so it's really easy to clean and even dishwasher safe. I love it, and I use it constantly. Our Place now has a full line of Titanium Pro cookware that uses this first-of-its-kind titanium non-stick technology. So if you're looking for non-toxic, long-lasting pots and pans, go to FromOurPlace.com/Huberman and use the code Huberman for 10% off your order. With a 100-day risk-free trial, free shipping, and free returns, you can experience this fantastic cookware with zero risk. Again, that's FromOurPlace.com/Huberman to get 10% off. Today's episode is also brought to us by LMNT. LMNT is an electrolyte drink that has everything you need, but nothing you don't. That means the electrolytes, sodium, magnesium, and potassium, all in the correct ratios, but no sugar. Proper hydration is critical for optimal brain and body function. Even a slight degree of dehydration can diminish cognitive and physical performance. It's also important that you get adequate electrolytes. The electrolytes, sodium, magnesium, and potassium, are vital for the functioning of all the cells in your body, especially your neurons or your nerve cells. Drinking LMNT dissolved in water makes it extremely easy to ensure that you're getting adequate hydration and adequate electrolytes. To make sure that I'm getting proper amounts of hydration and electrolytes, I dissolve 1 packet of LMNT in about 16 to 32 ounces of water when I wake up in the morning, and I drink that basically first thing in the morning. I also drink LMNT dissolved in water during any kind of physical exercise that I'm doing, especially on hot days when I'm sweating a lot and therefore losing a lot of water and electrolytes. They have a bunch of different great tasting flavors of LMNT. They have watermelon, citrus, etc. Frankly, I love them all. If you'd like to try LMNT, you can go to drinklmnt.com/Huberman to claim a free LMNT sample pack with the purchase of any LMNT drink mix. Again, that's drinklmnt.com/Huberman to claim a free sample pack. If I think about a mental health condition like depression, let's take depression to start off. I can just broadly create two, columns of things or approaches that one might take. One is this mental model of sort of a molecule deficiency. Like, I'm not saying this, but there are many who at one point thought depression is related to a deficiency in serotonin, or depression is related to a deficiency in dopamine, either levels, regulation, enzymatic control, whatever the level of control. Just this idea that these molecules are somehow lacking. If you put them back, you can relieve some symptoms of depression. The other column that comes to mind for me, having looked at the data on cognitive behavioral therapy, on the data on psychedelics in the clinical setting for the treatment of depression, SSRIs, and other so-called antidepressants, is this notion of neuroplasticity, the idea that neural circuits can change and that neural circuits control our sense of well-being, our perception of self, perception of others, feelings of agency, et cetera. And it's now very clear that if you change levels of neuromodulators like dopamine, like serotonin, you don't necessarily cure depression, but you open a window for plasticity, and then perhaps the therapy that you're doing can modify brain circuits more robustly. So I think in terms of molecule deficiency, maybe it's a vitamin deficiency, a neuromodulator deficiency, and then I also think about plasticity, that these treatments are just allowing for more brain change more rapidly. What other columns would you add to that picture? And perhaps first, do you think that picture is woefully inadequate or just partially inadequate? Because I think this is the way most people think about the treatment of mental health. They think, oh, there's something missing. You take a drug and you get that thing back. And then like ADHD, you don't have enough dopamine, or you put it in and then all of a sudden attentional circuits work better, this kind of thing, versus plasticity, which is the modification of those circuits. And the two things are not mutually exclusive. But I think until now, there really hasn't been a clear understanding that there are other columns for mechanistic change in mental health.
I would say the concept of metabolism, metabolic regulation, mitochondrial function, mitochondrial health actually is an umbrella concept for everything you've just said.
Mm-hmm.
It's an umbrella concept for, well, how do we create neurotransmitters? Where do these neurotransmitters come from? What regulates their production, release from cells? And then even to go further, what impact do those neurotransmitters have on other cells? They are largely regulating brain metabolism. And the way we usually think about it is they are regulating brain activity. But if you ask the question, well, what is brain activity? Brain activity is fueled by metabolism, that a neuron cannot be active unless it has the capacity to increase its ATP kind of production. And then when you suppress a neuron, when you inhibit its function, the ATP production goes down. So whether you want to think of metabolism as just a consequence of neural activity, I actually think about it as an integral part of neural activity. It's kind of like your car can't go without the engine. A cell can't go without mitochondria. A cell can't do what it's supposed to do without mitochondria. The other concept that you mentioned, neuroplasticity is all about energy and metabolic resources to create new connections, new neural connections between axons, dendrites, somas, other aspects of neurons and cells and other types of cells, astrocytes, oligodendrocytes. But in order to get neuroplasticity implies growth and modulation and even pruning, but it involves change. And in order for a living organism to change, that requires this foundational concept of metabolism. Now, on the surface, to a lot of people, that sounds too abstract, and it sounds like, well, that's ridiculous then. If you're saying that metabolism is everything in biology, and I kind of am, of course it is. You can't talk about biology without talking about metabolism. But when you talk about metabolic health, it becomes much more concrete, pragmatic, and real, with real tools that you talk about all of the time on this podcast. Exercise promotes metabolic health. Exercise promotes neuroplasticity. They are inseparable. You can't improve your metabolic health without also at least opening up the opportunity for neuroplasticity. Improving your diet does the same thing. Sleep, or lack thereof can impact this. Substance use can impact this. And so, in a way, it basically says, let's connect all of the dots. Let's not hyper-focus on serotonin and a serotonin imbalance or deficiency as the singular cause of depression. Because for those of you who don't know, that is ridiculously reductionistic.
Mhm.
And it is absolutely not true. We know that. We know that with certainty now. The whole serotonin hypothesis of depression came about not because researchers identified serotonin deficits in the brain. That entire concept came from the observation that medications that modulate serotonin activity or inhibit its reuptake into neurons, those medications, SSRIs, other types of antidepressants, those medications can reduce the symptoms of depression in some people. That was just a purely serendipitous finding. It was serendipity. The first antidepressant was actually a tuberculosis treatment. They were giving it to patients on a tuberculosis ward, and an astute infectious disease doctor noticed some of these patients are really depressed. But when I give them this tuberculosis treatment, they perk up. Like within a few weeks, they start looking a lot less depressed. And I don't think it's a coincidence. I think it's the medication I'm giving them.
Do you recall what the drug was?
Iproniazide. It's the first MAO inhibitor. And I could be saying the name wrong, but it's first MAO inhibitor. And that became the first antidepressant.
Which makes sense. MAO inhibitors inhibit the enzymes that break down, or let's just speak about these enzymes broadly. Either, I think most antidepressant drugs or treatments for ADHD, typical prescription treatments, either reduce the breakdown of neuromodulators like serotonin, dopamine, acetylcholine, depending on which one we're talking about, or they reduce the reuptake so that there's just more neuromodulator around for longer.
Yes.
Tell us about mitochondria in the framework of mental health.
So most people know mitochondria as the powerhouse of the cell, if they know it at all. So these tiny little organelles. And the powerhouse of the cell reference means that mitochondria take the breakdown products of the food that we're eating. They are the primary thing using the oxygen that we're breathing in. They are creating the carbon dioxide that we're breathing out, and that they are turning food into ATP, which is the energy currency of the cell. So they're taking food and oxygen and lots of other things, but let's just simplify food and oxygen, converting it into ATP. And that is what the powerhouse of the cell kind of refers to. There is no doubt they do that. There is no doubt that when that process stops, humans have about 6 minutes or so, and then we're dead. That process is critical to life. There is no other process in the human body that you can disrupt that will kill the organism faster. It is central to living organisms, this production of ATP. So I don't at all mean to take away or minimize that function, but research over the last 25 years has completely upended that simplistic notion of what mitochondria are doing. They are actually doing so much more. Some people have created the reference that mitochondria are like the workers inside a cell. That in order for a cell to work, you need a workforce because there's so much that needs to be done. Signals need to be sent, like all this work, all of these different things need to be functioning. And mitochondria are absolutely providing the energy for those things to happen, but they're also orchestrating a lot of it. So for example, they play a direct role in converting food into some of the substrates for the production of neurotransmitters. But they also go further. They store like some neurotransmitters like GABA within themselves, and that plays a role in GABA's release from a neuron. They actually go to the cell membrane and move along the membrane, dispensing vesicles of neurotransmitters. And when you take the mitochondria away from the synapse, but provide that synapse with ATP, vesicles don't get released. Neurotransmitters aren't getting released. The mitochondria are doing more. We don't exactly know what, but they're doing more than just providing the energy. They play a role in turning inflammation in immune cells both on and off. They help start the process, but they also help coordinate the cessation of that process. They play an instrumental role in both the first and the last step in the synthesis of cortisol. And they play a role in the first step in the synthesis of all of the steroid hormones, which include estrogen, testosterone, progesterone. So that if you have dysregulation of cortisol, or if you have dysregulation of testosterone or estrogen or progesterone, you must understand the role of mitochondria in that dysregulation, because they are critical in the production and release of these hormones. They are the primary regulator of epigenetics. So epigenetics are the expression of genes from the cell nucleus, and researchers have long known that that's related to levels of reactive oxygen species. It's related to levels of calcium. It's related to other cell signals. Those cell signals are mostly originating within mitochondria. During the development of any cell, mitochondria, they are like a universe unto themselves, and there's so much we don't know about them. But what researchers have found is that mitochondria actually literally line up in an organized fashion around the cell nucleus and take on different conformations. And that is somehow sending signals to the genes to result in the expression or the suppression of different genes from the nucleus. And that when researchers take these mitochondria and like mess them up or something, the cell doesn't develop normally. You know, they've been implicated in all of the phases of the human stress response to psychological stress. So that includes cortisol release, noradrenaline release. It includes inflammation, and it includes epigenetic changes. So those are kind of the four buckets of the human stress response: cortisol, adrenaline, inflammation, and epigenetic changes. And researchers actually manipulated mitochondrial genes, two genes in the cell nucleus that control for mitochondrial proteins, and two genes in mitochondria themselves. And by manipulating these four different genes, one at a time, in mice, they could impact all of the four aspects of the stress response. And so what that means is that mitochondria are somehow involved in regulating the human stress response. And so the way that I think about it is that, and the way that many researchers actually think about it now, is that mitochondria, you know, there are hundreds, sometimes thousands of them in our cells, in each of our cells. Most neurons have thousands of mitochondria. The mitochondria are actually moving around. They use the cytoskeleton to move around the cell. They fuse with each other. It's called mitochondrial dynamics. They like change shape. They do all sorts of things. And again, that impacts all of these signaling processes. But that's just within one little cell. So you can think of one cell as like almost a village. of mitochondria, that they're all just doing different things and working together to help that cell function. But in fact, when you think about hormones like cortisol, you can think about it as a way for mitochondria in one cell to produce cortisol that then gets sent to mitochondria in another cell to make that other cell do something, to either increase its activity or decrease its activity. Some people actually think about human cells as just a network of mitochondria, all kind of mitochondria throughout the body and brain are just doing all sorts of things. And at the end of the day, we come back to just common sense. At the end of the day, it's about helping the organism adapt and survive. Ultimately, organisms, rule number one, they need to survive. Rule number two, they need to reproduce. And rule number three, they need to adapt. And mitochondria are playing a foundational role in all of those basic aspects of organismal survival. And again, to some people, well, that's so high level. That's like, well, you're saying it's everything. I'm like, yeah, it kind of is. And mental health falls under it. How could we think about mental health without thinking about the big picture? Like, let's start with the big picture, and then let's put health into it, and let's put the lack of adaptation or the lack of survival or the these other things.
I'd like to take a quick break and thank our sponsor, AG1. AG1 is an all-in-one vitamin mineral probiotic drink with adaptogens. I've been taking AG1 daily since 2012, so I'm delighted that they're sponsoring this podcast. The reason I started taking AG1 and the reason I still take AG1 is because it is the highest quality and most complete foundational nutritional supplement. What that means is that AG1 ensures that you're getting all the necessary vitamins, minerals, and other micronutrients to form a strong foundation for your daily health. AG1 also has probiotics and prebiotics that support a healthy gut microbiome. Your gut microbiome consists of trillions of microorganisms that line your digestive tract and impact things such as your immune system status, your metabolic health, your hormone health, and much more. So I've consistently found that when I take AG1 daily, my digestion is improved, my immune system is more robust, and my mood and mental focus are at their best. In fact, if I could take just one supplement, that supplement would be AG1. If you'd like to try AG1, you can go to drinkag1.com/Huberman to claim a special offer. They'll give you 5 free travel packs plus a year's supply of vitamin D3K2 with your order of AG1. Again, go to drinkag1.com/Huberman to claim this special offer. Today's episode is also brought to us by 8 Sleep. 8 Sleep makes smart mattress covers with cooling, heating, and sleep tracking capacity. Now, I've spoken before on this podcast about the critical need for us to get adequate amounts of quality sleep each and every night. Now, one of the best ways to ensure a great night's sleep is to ensure that the temperature of your sleeping environment is correct. And that's because in order to fall and stay deeply asleep, your body temperature actually has to drop about 1 to 3 degrees. And in order to wake up feeling refreshed and energized, your body temperature actually has to increase by about 1 to 3 degrees. 8 Sleep automatically regulates the temperature of your bed throughout the night according to your unique needs. Now, I find that extremely useful because I like to make the bed really cool at the beginning of the night, even colder in the middle of the night, and warm as I wake up. That's what gives me the most slow wave sleep and rapid eye movement sleep. And I know that because 8 Sleep has a great sleep tracker that tells me how well I've slept and the types of sleep that I'm getting throughout the night. I've been sleeping on an 8 Sleep mattress cover for 4 years now, and it has completely transformed and improved the quality of my sleep. Their latest model, the Pod 4 Ultra, also has snoring detection that will automatically lift your head a few degrees in order to improve your airflow and stop you from snoring. If you decide to try 8 Sleep, you have 30 days to try it at home, and you can return it if you don't like it. No questions asked, but I'm sure that you'll love it. Go to 8sleep.com/Huberman to save up to $350 off your Pod 4 Ultra. 8 Sleep ships to many countries worldwide, including Mexico and the UAE. Again, that's 8sleep.com/Huberman to save up to $350 off your Pod 4 Ultra. What are some of the things that we know can improve mitochondrial health, either number, function, or otherwise? And maybe we could talk about the basics first and get a little bit granular, if you could, about, what are the prescriptions for keeping your mitochondrial healthy, or improving your mitochondrial number and improving their function. And then we can transition from there to the more, let's just say, the more advanced ways of doing that. Is there a role for supplementation? Is there a role for drugs? Is there, these days, I hear about Urolithin A. Because I'm a little bit of an adventurer these days, and I'm turning 50 later this year, I decided to experiment with a peptide that is SR31, which is specifically to improve mitochondrial function. I'm doing this with the full understanding it may do nothing or it may kill me. I don't know, but we'll find out. But someone had to do it, and I'm a one variable at a time kind of guy. So it was important for me to stay with my current regimen and only change that, do blood work, et cetera, because some people out there are more in the mode of trying to do a bunch of things, and I don't think that's as helpful to me. It's also just not. It's not in keeping with my nature.
Scientist.
I'm a scientist. One variable at a time.
That is great.
That's right. I'm monogamous with respect to variables. Right. So what can we do at a basic level to keep and improve our mitochondrial number and function? And if we have to hit on some of the usual suspects, fine. But if you could tell us how we can do this.
So I'm really going to start with the basics, and they're going to sound cliche and they're going to sound too basic to most people. And I just want to set the stage for, even for severe mental illness, we can talk about strategies that will work. And these strategies that I'm going to describe are not really appropriate. Like when somebody becomes severely ill, these strategies may not be sufficient. But the basics are what we call the field of lifestyle medicine. So there are 6 pillars of lifestyle medicine. They include diet, nutrition, exercise or movement, sleep, managing substance use, ideally reducing it or minimizing it or eliminating it, stress reduction practices, mindfulness, meditation, yoga, and the last one is relationships. I throw in the word purpose into relationships because I think even if you don't have a lot of friends or family, you can still have a very full, thriving life if you have a purpose. So those are the 6 pillars. Unfortunately, this is where the cliches and the worthless advice begin, especially in the diet nutrition camp, because people will say, eat more plants, eat some broccoli, have some good blueberries. Blueberries have antioxidants. Have some blueberries on whatever else you're eating, and everything will be fine. If you just add a couple of servings of blueberries a week, you'll improve your health.
Brain food.
And that it is such worthless advice. It is not at all that simple. And so I think diet nutrition gets complicated fast. The other things are actually pretty straightforward. Should you move your body? Yes. Should you stress your body intermittently, allowing for full recovery? Yes, that's what most people call exercise. And what are you doing when you exercise? You're actually, if we look at like the muscles, for example, muscle tissue, what exactly does exercise do? Whether it's isometric exercise to increase the size of the muscle, or whether it's endurance capacity, which actually does not change the size of the muscle at all, but allows for somebody to run longer, faster, harder. So marathon runners, for example, can be quite thin. You can look at a marathon runner and think you're not even an athlete. They don't look all that different, yet they can run sometimes 100 miles. And what makes their muscles different than my muscles, because I can't run 100 miles.
Me either.
What makes their muscles different than mine? Even if the size isn't different, there is one and only one thing that makes their muscles different, and it's called mitochondria.
The number?
The number of mitochondria, and almost certainly the health of mitochondria. You can actually take a biopsy of their muscle and you will see a much higher density of mitochondria in their muscle tissue than you will in mine. If you actually then did a more thorough assessment of ATP capacity their muscles or their mitochondria would be much healthier than mine. Their mitochondria would have greater capacity for ATP production than my mitochondria would. So that's exercise. There are lots of things you can do with exercise. For people who don't exercise at all, yes, get out and just walk. Just do something. Maybe get some sunlight in the morning while you're at it.
That sounds like a good idea.
The substance use is obvious. It's the thing you've been talking about. It. I've been talking
Which
about
substances deplete mitochondria? I've been very interested in this. I'm a big lover of certain genres of music, and whenever the topic of music comes up, the name Rick Rubin comes up because he's been on this podcast twice, the famous Rick Rubin, amazing producer, and I'm blessed to have him as a close friend. And I often ask Rick, I'm like, why are so many of these folks in music dead? There seems to be a history of people who did stimulants. It took a lot of stimulants, cocaine and amphetamine in particular. Musicians that did that in the 70s and 80s and 90s seem to drop dead of heart attacks later when they were not currently using, as far as we know, those stimulants. Is it the case that stimulants like cocaine and amphetamine deplete cells of mitochondria? Do we know that to be true?
We do know, and it's a slightly more complex story. So it's all about the dose. So stimulants are used to treat ADHD. And we know that we've known for decades, people who have ADHD, who have symptoms of ADHD, have glucose hypometabolism in their brains. So their brains are not producing enough ATP from glucose. What is one way to increase that? Dopamine. Dopamine will increase that. So you can give people stimulants to improve their brain metabolism enough so that they now no longer have symptoms, or at least have a reduction in their symptoms. That story is unequivocally true. We have lots of animal data, human neuroimaging data, clinical research studies documenting that appropriate doses of stimulants, so that's usually low-ish doses, can improve brain metabolism. And what that means is that they're actually stimulating mitochondria to produce more ATP. However, metabolism is all about balance. You can underdo it and you can overdo it. And when you overdo it, what happens is that if you hyperstimulate mitochondria with high doses of stimulants, the mitochondria are essentially running on all cylinders, and electrons start leaking out of the electron transport chain. And what happens is that creates reactive oxygen species, which then damage the mitochondria themselves and damage other aspects of the cell. And it can lead to chronic mitochondrial dysfunction, chronic metabolic dysfunction. It's challenging with stimulants because people are looking for a yes or no answer. So, Dr. Palmer, do you think stimulants are good or bad? I don't have an answer to that. It depends on the person. It depends on the dose of stimulants. It depends on the type of stimulant. It depends on what impact it's having on that person. But we need to open our minds to the possibility that, yes, maybe some people do benefit from stimulants, and maybe at the same time, other people are harmed in catastrophic ways by stimulants. And it can all be linked through mitochondrial mechanisms. It can certainly be linked through dopamine. But again, we have to ask, well, what is that dopamine doing to the target cells? That when dopamine gets released and connects with a dopamine receptor, what happens to that target cell? It changes the metabolism of that target cell. It increases the activity of that target cell. So stimulants are one, back to this bigger kind of lifestyle medicine picture. Stimulants are definitely one. High-dose stimulants, very harmful to human health.
What are some others?
Alcohol. we've known since the 1960s. In the 1960s, researchers were trying to figure out how the hell does alcohol cause cirrhosis? We knew that. We've known that. We've known that for a long time. Alcoholics develop liver failure. They develop cirrhosis of the liver, and they can die from it. How exactly does that happen? In the 1960s, researchers figured out it's mitochondrial toxicity.
Interesting.
In the liver cells. That is what's making the liver cells die. That alcohol gets converted into this molecule called acetaldehyde, which is very toxic to lots of cell parts, but in particular to mitochondria. Mitochondria are processing this alcohol, and other enzymes and kind of other things are trying to detoxify the alcohol. But at the end of the day, mitochondrial toxicity seems to be a clear route. So when I was doing research on mitochondria for the book, there were over 10,000 published research articles of alcohol and mitochondria. And I was initially shocked by that. And I wondered, like, what's that about? Like, how that's how I know this 1960s story and everything else is because researchers have been looking at how is it that alcohol can be so toxic? And the two organs that are most effective are the liver, because that's the primary organ trying to detoxify it, and then the brain. And why the brain? Because the brain is highly sensitive to metabolic disruption. Other substances of abuse, tobacco, the carcinogens in tobacco.
So not nicotine per se. Do we know if nicotine is depleting mitochondria?
Nicotine is a stimulant for mitochondria. So again, similar story. Low doses can be great. High doses may in fact be toxic.
Oh, good.
You gotta find the right balance.
I'm not a big nicotine guy, but lately I've started chewing half of a piece of nicotine gum a few times a week. So 2 milligrams to 4 milligrams, which is very low dose. Couple of, I would say maybe 3-4 days a week I'll do that. And I'm doing it specifically for brain health reasons. And I have no relationship to any nicotine pouch or gum or anything like that. So I want to be really like company. So I'm doing a little experiment, and it's an interesting stimulant because it relaxes you a little bit too. But I wouldn't want kids to start doing this, or people in their 20s or 30s. Like I said, I'm approaching the 5th floor. I'm going to be 50 in September. And I want to do everything I can to hold on to the neurons I've got. So I think low-level stimulation of perhaps the mitochondria and other, certainly the acetylcholine system with nicotine is a good idea. But what I see is a lot of people who are taking these pouches that range from anywhere from 3 milligrams on the low end dose side all the way up to 8 milligrams. And it is very habit forming. People start with 1 pouch or 2 pouches a day, and pretty soon they're doing a canister every day or two. So even the cost, it starts to be a big deal, but it's pretty incredible. I was on the Berkeley campus, and I went to a little convenience store near the Berkeley campus recently. This kid came in and we started chatting. A podcast fan, we were chatting, and he was there to buy nicotine pouches. I said, "How many of those do you go through a week?" And he's like, 7 or 8. I was like, "Really?" He's an engineering student. But in my years in college, it was always just, some coffee or something. Yeah, some coffee. We didn't really have.
I'd stick with coffee.
Yeah, for young folks. Yeah,
for the young
for
folks.
The young. A little bit of coffee.
And again, it's about dose.
Yep.
And it's about so most things that enhance metabolism quickly can be addictive.
Mm-hmm.
And I think that's the challenge for a lot of people, is that you get that energy right away. At some point, you acclimate to that substance somewhat, and then you want more. You want that same increase that you got before. So it's just important to kind of be mindful that you can overstimulate metabolism, mitochondrial function.
And then you start depleting mitochondria.
And And then, and then you actually, the mitochondria begin producing more reactive oxygen species, which ends up being detrimental. So it's like driving your car. Again, if you think about mitochondria like an engine, it's like an engine of your car. When you're driving your car on the highway, you don't want to go too slow and you don't want to go too fast. You
And
need to have
acceleration is
balance.
costly. And acceleration is costly, right? I mean, transmission systems, create this incredible efficiency of being able to travel at speed with more efficiency, but accelerating is a different thing altogether.
I mean, that's the way that I think about it. And so somebody who's addicted to drugs and alcohol, for example, they're on a roller coaster ride of hyperstimulating their metabolic rate and then trying to suppress that hyperstimulation with sedatives so that they can sleep or calm down. And then they're destroying their metabolic health. And does that really play out? And is that, some will say, well, Chris, that's just one of myriad things that they're doing to their cells. Sure. But does it play out in diseases that we think of as metabolic diseases? Absolutely. Type 2 diabetes, yes. Cardiovascular disease, 100%. Premature mortality, yeah. It's kind of like the elephant in the room that we have just failed to look at because we've been so splintered with, no, it's biological, no, it's psychological, no, it's social. It's like, it's all of them. Let's look at the elephant that comprises all of them.
One of the beautiful things about science is that you isolate variables. You can get very reductionist. We know that there are these things called mitochondria that they move around. I mean, these discoveries are truly incredible that have been made in the last 100 years or so. But there's been this kind of obsession, I think, in the public discussion around health that, around things that are obviously related to the thing that you're trying to cure. So serotonin and brain health. It's like, oh, okay, it makes sense. The Listening to Prozac book came out. We increase serotonin. Some people are feeling better. Maybe it's through neuroplasticity. Maybe it's direct effects of serotonin. But it makes sense. Serotonin, brain, right? But if we zoom out from that and we accept, because it's true, that essentially all cells are dependent on mitochondria for their function, why wouldn't we go to this fundamental layer first in order to try and improve mental and physical health simultaneously, right? It's a very different way of approaching medicine in general. Normally we go, okay, well, the issue is right here. That's where the tumor is. That's where the circuit deficit is. This is where the lesion is or the growth, and we're going to go there, right? But to avoid the pathologic state in the first place, these 6 pillars are wonderful, by the way: a diet, exercise, sleep, substance overuse or abuse, stress mitigation, and relationship/purpose. So we're going to keep returning to this theme of mitochondria as foundational throughout today's discussion, because I think people need to frame their health in that context. I really do. Also, years ago, my postdoc advisor, the late Ben Barris, he died unfortunately of pancreatic cancer, but just seeing incredible scientist, MD, and scientists who really popularized the study of glia. Prior to that, they were seen as kind of like backwater science. Everyone thought it was just glue for the brain. He used to stop us in the hallways late at night, and we called it getting bend, because you'd want to leave, and he would he was a night owl. It was awful, and you'd get stuck there. But I'll never forget, he stopped me. He called me Andy, and he said, he did this numerous times, but he said, Andy, why? No one calls me that, by the way, anymore. He said, Andy, why is it that as we get older, we have less energy? And I'm like, I don't know, Ben. He's like, someone needs to, he's like, why don't you work on that? Why are you working on these retinal cells? Like you should work on that. And he said, why is it that our brain is less plastic? I'm like, well, I don't know. I think it's the glia, right? And there is some evidence that it has something to do with the glia, among other things. But there's a fundamentally interesting question. When you look at kids and they're just full of energy, and there's the NAD hypothesis, and there's these other, but it always seems to circle back to mitochondria.
Yes.
Over and over. So I think the answer is very clear. We have a ton of mitochondria early in life, and over time it gets depleted. Is it that simple? I mean, there are other things too.
There are other things, but I actually do think it's not just the number and density of mitochondria, but it's the health of mitochondria. Because unfortunately, our cells have a process for getting rid of defective mitochondria. It's part of autophagy. There's a sub kind of category called mitophagy, in which defective mitochondria should be shuttled to lysosomes or shuttled out of cells. Recent paper actually found that microglia in the brain, again, send out these nanotunnels to astrocytes and collect defective mitochondria from the neuron.
Amazing.
And then take care of the disposal process for that neuron.
Glia are so cool.
And that when you inhibit that, it appears to increase and accelerate neurodegeneration. And when you enhance that, it appears to improve or reduce neurodegeneration. But I think it is. I think children have more energy because they have healthier metabolism, healthier mitochondrial function. And when we look at again, is there evidence for that? There's overwhelming evidence for that. There are thousands of peer-reviewed, published articles in leading journals, Nature, Cell, all sorts of journals over the last several decades. Just to, again, try to bring this back to just common sense. So we have these things called diseases of aging. What are the diseases of aging? The diseases of aging are obesity, type 2 diabetes, cardiovascular disease, cancer, neurodegenerative disorders. Those are universally thought of as diseases of aging. Interestingly, what often gets left off of that category are the mental disorders. Especially today, a lot of people think of mental disorders as primarily a youth problem. But in fact, mental disorders, depression, anxiety, psychosis, are actually diseases of aging. So the Center for Disease Control has put out kind of charts of any age group. What is the probability if you are, a youth in America today that you will be prescribed an antidepressant, an SSRI antidepressant? If you're between 20 and 40, what's the probability? Among the remaining people who are still 20 to 40, among all the people that age, as people get older, the risk for antidepressant prescription goes up. The highest category of people prescribed antidepressants are 65 and older.
Really? Well, I guess some sense that makes sense, although I would have thought it would be the younger population.
Most people do, and that's why I'm saying this, because it's shocking to most people. It was actually surprising to me, but I was thinking, wait, if my theory is correct, then mental disorders should be a disease of aging. And in fact, they are. Antipsychotic prescriptions, what age group is the most likely to be prescribed an antipsychotic? Over age 80.
Really?
Oh, it goes through the roof. Because dementia is associated with 40 to 50% of the people with dementia will have psychotic symptoms, hallucinations, and delusions. They'll have agitation. The benzodiazepines, the prescription rate goes up. Now with benzos, there is a dip starting at age 65. And that is really because physicians are explicitly told, do not prescribe benzos to people over 65. So the rate starts going down.
Interesting.
But with antidepressants, it's almost linear. The older you are, the more likely you are to be receiving a prescription for an antidepressant. Antipsychotics, there are some waves and shifts. Women, for example, around the time of menopause, get a peak. So you get a peak around the age of 20, which is new onset schizophrenia. And then it kind of comes down a little. And then women, around the time menopause, higher peak. And then it kind of comes down a little. And then late in life, goes through the roof. goes through the roof. Again, because of what we call dementia. So the diseases of aging, anyway, are all of the metabolic disorders and, oh, by the way, the mental disorders. And in my mind, we need to tie that together. That is not a serotonin problem.
Right.
We need to tie that science together. And the only way to tie that science together is to look at the bigger picture that we call metabolism. And ultimately, you have to look at mitochondria and mitochondrial biology to understand it.
I'd like to take a quick break and acknowledge one of our sponsors, Function. Last year, I became a Function member after searching for the most comprehensive approach to lab testing. Function provides over 100 advanced lab tests that give you a key snapshot of your entire bodily health. This snapshot offers you with insights on your heart health, hormone health, immune functioning, nutrient levels, and much more. They've also recently added tests for toxins such as BPA exposure from harmful plastics and tests for PFASs or forever chemicals. Function not only provides testing of over 100 biomarkers key to your physical and mental health, but it also analyzes these results and provides insights from top doctors who are expert in the relevant areas. For example, in one of my first tests with Function, I learned that I had elevated levels of mercury in my blood. Function not only helped me detect that, but offered insights into how best to reduce my mercury levels, which included limiting my tuna consumption. I'd been eating a lot of tuna, while also making an effort to eat more leafy greens and supplementing with NAC and acetylcysteine, both of which can support glutathione production and detoxification. And I should say, by taking a second Function test, that approach worked. Comprehensive blood testing is vitally important. There's so many things related to your mental and physical health that can only be detected in a blood test. The problem is blood testing has always been very expensive and complicated. In contrast, I've been super impressed by Function's simplicity and at the level of cost. It is very affordable. As a consequence, I decided to join their scientific advisory board, and I'm thrilled that they're sponsoring the podcast. If you'd like to try Function, you can go to functionhealth.com/Huberman. Function currently has a wait list of over 250,000 people, but they're offering early access to Huberman podcast listeners. Again, that's functionhealth.com/Huberman to get early access to Function. Let's talk about diet and nutrition for a moment. In recent years, you've talked a lot about the clinical use of the ketogenic diet for various mental health disorders and cited some spectacular results. And this has had a huge impact on everybody's thinking about what ketogenic diets originally were for. It was developed as a medical treatment for epilepsy, is my understanding. Only later did it become popular as a potential avenue for losing body fat, et cetera. But what are some of the ways that people can use diet and nutrition to improve metabolic health generally, but let's be more specific, mitochondrial health, number, turnover, all the good stuff that happens in mitochondria. How can nutrition be used to improve that? And why would it be that the ketogenic diet would improve mitochondrial function? Or is it that the ketogenic diet bypasses the need for standard cellular metabolism by pulling on some other cellular metabolism mechanisms? I'm just trying to draw the link here between ketogenic diet and mitochondria, because you've well established that mitochondria are central to this whole picture of mental and physical health.
I'll throw in a plug before I go deep into the ketogenic diet story, but you also threw a question in there about other dietary interventions or how can diet impact. There is no question diet plays a profound and central role to human metabolism and all of the consequences of human metabolism. And you very eloquently laid out the case for early life. A woman who's breastfeeding her infant, that breast milk has a profound impact on whether that baby's brain develops normally or not. That has dire consequences potentially for the outcome and the health of that child. And it's all about nutrition. We've known that for decades, that if women are malnourished during pregnancy, it impacts that infant's, the fetus's lifespan, really. It increases risk for mental disorders and metabolic disorders. Increases risk if your mother is starving while she's pregnant, or has to fast, or has to go without nutrients, it increases that child's risk for metabolic disorders, obesity, diabetes, cardiovascular disease. We've known that. And that is, there are lots of theories about obesity around that. It also, surprisingly, increases risk for schizophrenia and bipolar disorder and antisocial personality disorder and all sorts of other mental disorders. In terms of other dietary patterns, I just want to, and we can do a deep dive into any of these if you want, and then I'll go on to ketogenic diets, but ultra-processed foods, really bad for your physical health and your mental health. We have just growing body of evidence for that.
Is that because of the increased calorie consumption? There's this really nice paper that was published a few years ago showing that people who eat above a certain threshold of processed foods tend to consume on average about 500 calories more than they require per day, which might not seem like much, but over time that compounds and they gain a lot of adipose tissue, and then the adipose tissue is secreting a lot of things into the bloodstream that make the whole situation even worse, both brain and bodily. But aside from the caloric load, I mean, is there any evidence that these food dyes and other things that are included in these foods are detrimental to mitochondrial health? This is a somewhat controversial thing these days because some of these dyes were banned recently, which I saw as a good thing. But then some of the diehards in the scientific community were like, oh, those dosages represent like 6,000-fold what you'd have to eat, what most people eat, the dosages used in mice. But the FDA still pulled those dyes, and the FDA is a pretty conservative body. So I don't know. Not every chemical is bad, of course. But are these additives really that bad?
So to try to answer your question, are the chemicals and additives harmful? The real answer is we don't actually have adequate scientific evidence one way or another. And why don't we have adequate scientific evidence? Because we're not spending money to research it. So right now, the rules to this day are that, there's this concept called GRAS, general regarded as safe, that food companies can develop new molecules that will preserve a food, make a food hyper palatable, make it tastier, make it more shelf stable, whatever they want to claim it does. But they can develop molecules. They can put these molecules into our food, and they can get away with just saying, well, this is just generally regarded as safe without any adequate safety testing whatsoever. And the FDA allows that. Now, the new administration, RFK Jr. just recently said he's going to try to change that rule, and I welcome that change. I think that will be a phenomenal change. But the reality is that testing hasn't been done on all of these molecules. There are tens of thousands of molecules and like new chemicals, new additives, things that sometimes aren't even on the label that are added to food. And we really don't know for sure for each and every one of them whether this one is safe or not safe. What we do know overall, and this unfortunately comes down to epidemiological studies where they just look at hundreds of thousands, if not millions of people, and they assess like how much ultra-processed food is this person eating, and is that associated, if we look at large populations of people and we stratify them by these people are eating mostly ultra-processed foods and these people are hardly eating any, are there differences in their health outcomes? And the answer to that is unequivocal, and it is perfectly clear. The more ultra-processed foods you eat, the worse your physical and mental health, both. It's cardiovascular disease, it's obesity, it's diabetes, it's mortality, it's cancer. It's also a broad range of mental disorders. And So we know that. We've got more granular data that's hyper focuses on the mental health story. One study over 300,000 people, the more ultra processed foods you eat, a direct linear relationship. It was shocking how linear it was. The more ultra processed foods you eat, the worse your mental health. And it was so striking. It was not a subtle difference. It wasn't like, it was a 3% difference between the lowest. It was a threefold difference.
Wow.
The people who consumed ultra processed foods every day, multiple times a day, 58% of them had poor mental health, compared to only 18% of the people who rarely or never consumed ultra processed foods.
Wow. So this would be even just like somebody has like a bag of chips and some, just pour in water type pre-made soup or something like that. Those are ultra processed. This would be somebody orders a sandwich at the deli for lunch, which can be done in a relatively healthy way, depending on what's in that sandwich. And then does soda and bag of chips on the side. Like, I mean, that's a lot of, in my opinion, highly processed food. But I think sometimes people don't think of it that way.
Yes.
I was surprised and somewhat delighted to learn that one of the ways that the public health folks got kids to smoke fewer cigarettes. Because when I was growing up, like smoking was cool. Like if you smoke a cigarette, it was cool. People thought it was cool. It definitely is reinforcing because of the nicotine, the dopamine increases, and it was considered cool. You had your like Marlboro Man image from the preceding decades, but then it was really the 90s kind of. It was the actors and models and stuff that made it cool. Like people smoked and it was supposed to be cool. And one of the ways that we ended up with people smoking far less was not just to ban it on campuses, because that just makes teens want to do it more, right? In college, you want to do it more, was to have these commercials of these, it was all, to be direct, it was just like these rich white guys in a room that was portraying like the boardroom of a tobacco company, and they were like cackling and talking about like, ha ha ha, they don't think it causes cancer and this kind of thing, basically pitting youth against adults so that the youth felt like their money was being taken by the establishment. So is there a world where, kids are going to be like, forgive me, but, like, F that, I'm not eating Doritos, like I'm not going to be manipulated by highly processed foods, or I'm going to hold on to my mental health by making healthy choices in terms of food. It's tricky, but it has a lot of the same parallels to cigarette use or alcohol use. But I feel like the only way to really get Americans to change their behavior, besides scaring them fundamentally, but even if you do that, is to incentivize it. And one of the best incentives historically for public health change has been to make the public feel like they're pitted against the people that are trying to take their money unfairly and make them unhealthy at the same time. You got to activate that kind of rebellious spirit. Not going to do it. Just telling people it is bad for you doesn't work, right? We know that. How do we incentivize people?
Yeah, I'm not going to give a cliche answer because this is the $1 trillion question that everybody's asking, and it really, the health of our country really kind of depends on it. With billions of dollars that this industry has in revenue annually, they can spend a lot of that money on really impactful marketing campaigns, getting people to believe that it's not as unhealthy as Chris Palmer and Andrew Huberman are saying. It's fine. Everybody deserves a treat. Within the last couple of weeks, the American Heart Association was actively lobbying against a Texas bill that was trying to restrict spending food stamp money on junk food.
I saw that clip. It's so disturbing to see someone from the American Heart Association actively lobbying to keep tax dollars directed towards including sugary soda, not even diet soda, but sugary soda in lunches and food for people who are low income.
And he went on record as saying this junk food, this ultra-processed food, is not the root cause of obesity or diabetes or any of these health conditions, which is an absolute abject lie. And when you have supposedly respected organizations being bought by industry, promoting misinformation, it's really hard. Everybody's all upset that, like, oh, people don't trust the science. They're not respecting the respected organizations. Well, the respected organizations need to step up and start behaving in a respectable manner. They need to stop. The American Heart Association should not be taking a dime from any industry that plays a role in heart disease. Like it would be like the American Heart Association taking money from tobacco companies and then coming out and say, smoking doesn't really cause heart disease, people. Everybody calm down. There's still a lot that we don't know. We need more research. Smoking doesn't cause heart disease, people. This is just scaremongering.
And that
this
happened.
is just paranoid conspiracy theories. That is exactly what's happening now. They're taking money from food companies that have no vested interest in the health of the population that they are feeding. They know perfectly well that these foods are highly palatable. And what does that mean? It means addictive. And again, if I was selling food, I would want people to be addicted to the food I was selling. Why? Because you sell more. Higher margins. If you sell food that people aren't addicted to, they'll just move on to the other food that is addictive, and then you'll be out of business. So it's not an easy problem to solve. I don't mean to imply it's easy, because if one or two companies steps up and does the right thing, they'll just go out of business.
Well, I feel like the smoking parallel is critical, and maybe the trans fat, the history of entire cities banning the use of trans fats, for instance, or the use of styrofoam containers, right? I mean, it's very different issue. This doesn't directly get to human health, although styrofoam is not good, but it's about waste and environment. But I feel like there has to be a top-down ban, and Americans also don't like bans, right? We don't like things. We like choice, but we don't like the consequences of choice. And then we want people to fix the consequences of those choices with treatments that don't have side effects. And then this is like kind of the cycle that I've observed in my lifetime over and over again. I think it's the rebellion piece. It's when people realize they're being manipulated. Once people realize they're being manipulated, I feel like that's when they're willing to intervene and stop a otherwise reinforcing activity, reinforced addictive activity, save money, and like take a different direction. Like that's inherent to the American spirit. As much as we love freedom, we have this like, no, you're not gonna do this to me kind of spirit. We see it everywhere. This is my belief. But then again, I was kind of a rebellious teen. But if it's in service to health, why not?
I'm hopeful. I mean, my understanding, by no means am I an expert, but my understanding of what really drove the reduction in tobacco use was the taxes and the ban on advertising, the ban on television advertisements.
Interesting.
That when you get rid of the advertisements, you're no longer tempting people with it. You're no longer able to spread misinformation. And when you make the product so expensive, people just, even if they want to try it, even if they're already addicted to it, now they are highly motivated to get off of it. Why? Because it's costing them an arm and a leg.
Yeah, money hurts.
And they realize that I just don't want this. We could do similar things with ultra-processed foods. If rebellion, education, whatever, I don't care what works.
All
But
of the
but
above.
we're all of the above. We're really fighting an uphill battle. So ultra-processed foods, that's just one story. Vitamin nutrient deficiencies. Do you want to go to ketogenic diet? You asked me about that and I got sidetracked.
Yeah, we went into a public health discourse. We're weaving back and forth. That's what we do here. I think look, it's very timely, right? I don't care if you're the staunchest Democrat or the staunchest Republican or somewhere in between. Like, these issues affect everybody. And anyone who just wants to view MAHA as a Republican thing, it's fine. That I'm not affiliated with MAHA. I am in favor of improved public health from whatever angles that can meaningfully be done. So tell us about ketogenic diet, and then I'd like to ask about things that we can do to improve mitochondrial function in these other bins. But does ketogenic diet improve mitochondrial function? And if so, how does that work?
The quick summary story for people who don't know ketogenic. So ketogenic diet is a 100-year-old evidence-based treatment for epilepsy. It can stop seizures even when medications fail to. We have over a dozen controlled trials of ketogenic diets in children in particular with treatment-resistant epilepsy. We have 2 Cochrane reviews that came out positive. So Cochrane reviews are the gold standard in the medical field for meta-analyses. Very rigorous, and they analyzed the data that exists and came to the conclusion that ketogenic diet, if somebody has treatment-resistant epilepsy, compared to treatment as usual, which is try another anti-epileptic medication, the ketogenic diet is 6 times more likely to result in seizure freedom.
Wow.
Than just trying yet another epilepsy pill. So the ketogenic diet is a powerful anticonvulsant treatment. We use anticonvulsant treatments in psychiatry every day in tens of millions of people. Lots of these medications are used. So, so at this point, we now have over 50 published pilot trials, case series, case reports, other lines of evidence of the ketogenic diet for psychiatric disorders, schizophrenia, bipolar disorder, depression, anxiety, anorexia nervosa, surprisingly. These 50 reports represent over 1,900 people, and on balance, the ketogenic diet appears to be an effective treatment, sometimes an extraordinarily effective treatment, like able to induce remission of schizophrenia or bipolar in people who otherwise had treatment-resistant disorders.
And they're going off medication simultaneously?
Some of them are. So there are, I have heard probably from thousands of people around the world since my work has become more public. And actually, our first podcast together, hands down, the most cited reason people know who I am.
As they should.
Well, I know about you, but it's Huberman, that Huberman Lab podcast.
Well, I'm just a runway for people to incredible messages to take off.
Thank you again for the opportunity to disseminate this word, and because at the end of the day, I'm hearing from thousands of people who simply listened to that podcast, made changes, started a ketogenic diet for their schizophrenia or other treatment-resistant mental disorder, reach out to me. You saved my life. I can't tell you how many times I've gotten handwritten notes, emails, messages from people who use those words. You saved my life. I never met this person. All I did was share this knowledge. And then they saved their own lives with knowledge. Coming back to your question now in a roundabout way, does the ketogenic diet impact mitochondrial health? We have strong evidence that it does. And so it appears, so the ketogenic diet is mimicking the fasting state. And I just want to say that again. The ketogenic diet mimics the fasting state. What does that mean? It means the ketogenic diet is mimicking no food consumption. So is the ketogenic diet the healthiest diet that everybody should follow? No, that's not the way I think about it. The ketogenic diet is an intervention. It is shifting metabolism. It is shifting countless kind of systems, signaling pathways, other things, gene expression in the human body and brain. And that results in effects. And the good news is these effects appear to be life-changing and life-saving sometimes. So they're highly beneficial effects. Again, dose and the way you do it matter, because fasting, the extreme version of fasting is starvation, and that results in death. So that is not at all a good
Not
thing.
feasible.
So let's make sure that if you're going to do a ketogenic diet or a fasting regimen, that you're not depriving yourself of essential nutrition, that you're getting enough calories, you're getting enough nutrients, that you're doing it in a medically sound way so that you're optimizing your health and not hurting your health. But we have, it's hard to measure this in humans in vitro, because we can't do an intervention to a human and then dissect their brain and biopsy it and look at the mitochondria under the microscope. So we mostly have animal data that supports this, but animal data strongly supports that ketogenic interventions improve mitophagy, so getting rid of these old and defective mitochondria. So you're kind of cleaning house. You're getting rid of the bad, and then you're replacing them with new, fresh ones, mitochondrial biogenesis, so that at the end of the day, the cell will have more healthy mitochondria. Now, some researchers have really hyper-focused on the ketogenic diet might be working through the gut microbiome, this gut-brain connection. And we have some evidence that that is true. So researchers actually took feces from human children with epilepsy before starting a ketogenic diet, and then afterward while they were stable on a ketogenic diet. And then they transferred these fecal samples to mice who were predisposed to epilepsy or predisposed to seizures. When they took the feces from the children while the children still were seizing, the mice were more likely to seize. When they took the feces from the children doing the ketogenic diet and transferred it to the mice were less likely to have seizures.
Interesting.
Even though the mice were not on ketogenic diets. So there's something in the feces of children with epilepsy doing ketogenic diets that has an anti-seizure effect. What could that something be? It could be the gut microbiome, but it could be molecules, neurotransmitters, neuropeptides, other things that those microbes are producing, or it could be neuropeptides and other factors that the gut cells are producing. So we really don't know for sure what exactly is it. So on the surface, there's something in the feces, there's a gut microbiome, a gut-brain connection thing. What does that have to do with mitochondria? So another research group did that same model, got mice to have an anti-seizure effect from a ketogenic diet, and then dissected their brains, looking for what changed in the brain. How exactly is a ketogenic diet having an anti-seizure effect in the brain? Because that's the pathology, the pathological finding, seizure, is occurring in the brain. And when they analyzed genetic changes, upregulation, downregulation, it all centered on mitochondria. That the changes in the gut were resulting in mitochondrial changes in the brain, which means brain energy metabolism in the brain. And so again, it's an umbrella theory, doesn't replace what we know. It's not gut microbiome or serotonin. It's not gut microbiome or mitochondria. It's both. Both of them are true, and it's all interconnected. So I do think we've got more than enough data that ketogenic therapies impact brain metabolism, which then impacts neurotransmitters. That's really what I hope will become one of many really important studies published by Ian Campbell and colleagues in the UK that they just did a pilot trial, 20 patients with bipolar disorder, put on ketogenic diets, and they found wide-ranging improvements in metabolic health biomarkers like weight, blood pressure, other things. But they also found a reduction in brain glutamate activity, which is often associated with bipolar disorder and hyperexcitability and seizures. And so that helps us understand, again, it's not metabolic or glutamate, a neurotransmitter, it's both. It's putting it together.
Yeah, the Campbell study is really interesting. We will link to that in the show note captions. And incidentally, we will also link to this American Heart Association appalling quote unquote testimony.
Sorry, AHA.
Yeah, I'm not sorry. I'm not sorry. But then again, I'm not a physician, so I don't have to worry about that. Well, maybe I do. Anyway,
I'm not a cardiologist.
Is there any rationale for people who don't have epilepsy or don't suffer from bipolar or schizophrenia, but like myself, would like to keep our mitochondrial function as strong as possible, and for doing a brief ketogenic intervention?
Yes, the answer is yes. Can intermittent, and I'm going to lump ketogenic with other fasting mimicking diets and fasting itself. So can intermittent fasting or can cycles of fasting have health improving qualities or health improving effects? Absolutely. So interestingly, before I talk about even some of the science on this, and it's not super robust. Why? Because again, we don't fund diet studies. There's no money to be made from dietary interventions.
Really?
There's no patent on it. Nobody cares about dietary interventions.
But there are a lot of studies on exercise interventions.
But even those they're not huge randomized controlled trials with 10,000 participants. They're not, like even the federal government will fund large scale medication trials, statin studies and others, but they often don't. I mean, there have been a few. The Women's Health Initiative funded a massive dietary intervention study. And unfortunately, that was a huge disappointment to the field because it was negative. They randomized women to just keep doing the diet you're eating or go on a low-fat diet. And the low-fat diet didn't do anything for their heart health or other objective kind of outcome measures. And put another way, just to really close this for people, it means a low-fat diet is no better than the standard American diet. A low-fat diet is equivalent. You get equivalent health effects from a low-fat diet to a standard American diet. That's really bad. So low-fat diets need to go away. And people who promote low-fat diets need to stop promoting. They need to come up to speed with the science and just move on. At least acknowledge there are healthy fats. Even though fat has more calories, don't worry about those calories. Worry about the health effects, the long-term health effects.
Yeah, you got to get those monounsaturated fats, and you got to eat your omega-3s, and you have to and I'm a believer in eating some butter here and there.
You were asking me about intermittent
Yeah.
ketogenic diets or
intermittent fasting.
So I'll just say that we have a long history in multiple cultures on Earth for thousands of years. Fasting has been part of healing rituals. India, China, Christian, like fasting has been a part of rituals. And, most people just assume it's religious folklore or just silliness or whatever. But I actually think millennia of humans were not all stupid idiots, and that some people along the way actually noticed this seems to do something useful. And that's probably why it found its way in every culture and persisted for thousands of years, because there was actually something meaningful happening. So what we have now in terms of more controlled trials, I'm going to cite Walter Longo, who he doesn't call his diet a ketogenic diet, although it is a ketogenic diet. He calls his diet a fasting mimicking diet, and it's primarily a plant-based 600 calorie a day diet.
Some people are going to hear that and just gasp.
It is proprietary to him. I have no relationship with him. I'm not promoting his product, but he has a proprietary product called Prolon. You can get the benefits by just not eating anything or by eating 600 calories a day. I mean, you don't need to buy that proprietary product. But because he is selling this product, I believe he's using most or all of the funds most or all of the proceeds from the sale of that to fund research on it. They've done a series of studies that 5-day cycles several times a year seem to be fine and improve a wide range of health biomarkers.
Interesting.
And there's reason to believe that it may help improve metabolic health and longevity. So he's primarily a longevity aging researcher. He is promoting that. Could ketogenic diets also produce similar effects? I believe they can. Again, it gets really controversial fast because ketogenic diets can sometimes include red meat. And then we got the American Heart Association telling us that red meat's bad for you and don't eat that red meat.
Nonsense.
And and we get these splintering groups, and we've got the vegan group saying that's awful for you. And unfortunately, it just leaves people confused about like what are we supposed to do? Do we eat red meat? Do we not eat red meat? Do we
in moderation from healthy sources? I feel like in moderation from healthy sources, not the processed stuff. But I get it. People have animal reasons or environmental reasons they don't do it. The debate goes on and on. I've observed some people who are vegan who seem very healthy, very robust. Aesthetically, they present well, if I'm just going to be direct about it. And then I've seen some people who go vegan and it's the exact opposite. And then I've seen, I think the strict carnivore thing seems to work for very few people, but the ones who love it really love it. But even the folks like Paul Saladino, who were the so-called, carnivore diet then it became animal-based, and it now includes fruits and cucumbers and tomatoes and some dairy and so
honey
and honey and I like Paul. I get along well with Paul. I also get along with Lane Norton, and they don't get along. But I think it's to each their own within the context of the correct number of calories for a given person and their activity levels. But this idea of doing periodically doing perhaps a fast along the lines of the Longo Prolong thing, or a total fast or water fast, I guess it's called, or perhaps intermittent fasting on a more reasonable schedule. Are there any data on that? Like eating only between the hours of, say, 11 a.m. and 7 p.m., which is what I happen to do reflexively, unless I wake up very hungry, which is really rare. I don't know why. Maybe it's a function of getting older. But is there any evidence that intermittent fasting that doesn't involve entire day and night fasts, but more of the, time restricted feeding to 8 hours or 6 hours, that it can be beneficial for mitochondrial function if it's done for short bouts of 2 to 4 weeks?
My understanding of the literature is that it's a mixed bag when it comes to time-restricted eating and intermittent fasting. Because more often than not, they don't control what people are eating when they're eating.
Oh, well, that's no good.
So they just, those studies mostly are designed to just say, don't eat. Only eat between 11 a.m. and 7 p.m.
So it becomes
And eat whatever you want, but it doesn't matter. Like, and as though it doesn't matter what they're eating. And some people are binging on ultra processed foods, and others are eating like an adult. And then you've got everything in between, as though that doesn't play a role.
Right.
And so you get these studies that say it doesn't do anything useful. You get other studies that say maybe it does something useful. So I think, I mean, at the end of the day, I will say this, I've been talking a while with a really seasoned, established expert in the nutritional space, in the conservative nutritional space. He's held several government positions. He's helped presidents and others with campaigns. And he has made a very strong case to me that, less than 5% of the research budget from the NIH is spent on nutritional research. The NIH has an office called the Office of Nutritional Research, focused on organizing collaborations among different NIH institutes and centers. And their annual budget for a major government organization, their annual budget is $1.3 million with an M dollars.
Oh my goodness. That's
which is a joke.
Yeah,
it is a laughable joke.
Can't do much with that.
And without trying to make this political, there have been people who've tried to increase the funding for nutrition research. Recently, it was proposed to increase that funding to $130 million, and it was cut. That idea was killed by the lobbyists of the food companies.
I'm going to get really vocal about this lobbying through the American Heart Association thing, because I was just shocked, right? For all the obvious reasons. American Heart Association, you assume that they are all about healthy hearts, and we know metabolism is, and healthy weight and activity and all that is healthy for hearts. And it was so clear that they were on the take from these food companies, and that's why they sent, even just the timing and the delivery. Again, I'll post to the link because it's just like jaw-dropping. Like, I can't believe this. It's like the old commercials of the people from the cigarette industry saying, yeah, the cigarettes don't cause cancer, and they know it does. And this is happening now in real time. And this conversation will certainly assist in drawing attention to this. I'll probably do a social media post on it as well. But there's this thing that happens in medicine and public health where the thing that's so obviously the problem is, like, it's not even staring us in the face. It's like slapping us in the face. And we take 20 to 30 years relying largely on messaging through Hollywood, kind of what actors are doing, what athletes are doing. Then people are like, oh yeah, maybe this is a thing. And then the battleship just eventually just pivots. But there's been decades of horrible misfortune and loss in mental health and physical health, people thinking that there's something wrong with them, or, et cetera, et cetera. I mean, it's asinine. It's crazy. And so I'm excited about MAHA, even though I don't have any affiliation to it, because it's the first time in my lifetime that anyone said, like, hey, let's actually just talk about and think about how to really get healthy. What do we know right now? And so I'm not a political person, but I think it's really important that we get focused on what's literally slapping us right in the face with, like, this is absurd. Forgive me for editorializing here, but we keep coming back to this. We know what we need to do.
We know what we need to do, but yeah, we have not had the political will to do it. I think the hope is that, one, hopefully of many good things that could come out of MAHA, is separating industry interests from the health and welfare of the American population. I think if we can do that, and we can begin doing unbiased research to really determine what is it about ultra-processed foods that results in harm. We know they result in harm. Is it just that they're so delicious that people consume extra calories and it's still just as simple as calories? Or is it that there's something in those chemicals that makes the foods addictive? Or is it that there's something in those chemicals that actually impairs mitochondrial function? I think we have evidence to support all three of those hypotheses. Do people consume extra calories? Yes. You cited one of now many studies documenting that. Are they addictive? Yes, unequivocally, they are. The most common eating disorder diagnosed today in the United States is called binge eating disorder. What are the criteria for binge eating disorder? It's basically addiction to ultra-processed foods is really, if you look at the criteria and if you look at the behaviors, when people engage in binges, they're not binging on steak and broccoli. Ever. Like never are they binging on steak and broccoli. They're binging almost exclusively on ultra-processed foods. And then they go through these cycles where they binge on them and then they beat themselves up and they feel disgusting and they're ashamed and they're humiliated and then they try their best, they white knuckle it to avoid those foods, and then something bad happens in their life. They get stressed, somebody cuts them off in traffic, they've had a hard day at work, their boss came down on them, whatever, and then they go home and they're like, screw it, I hate my life, I hate myself, health doesn't even matter for me. I'm
Classic
worthless,
addiction cycle.
and I may as well just enjoy myself. And just like an alcoholic would, just like a cocaine addict would. It's not that people are using every single day. They go through cycles. And it's really tragic. Harvard Medical School just literally 2 days ago came out with an article, Is Sugar Addictive? And their conclusion, no, because sugar is found in fruit, so it can't be addictive. I'm like, really? Is that? And they
Not
actually
the same sugar.
They went out of their way to say, well, it's not like addictive like alcohol and nicotine because people sometimes have trouble stopping those completely. And I'm thinking, and what do you think is different about sugar? like,
Unbelievable.
do you really don't understand that some people can't stop consuming ultra-processed, high-sugar foods? You really don't understand that? Like, are you living in an ivory tower?
Yes, and I'm not. I'm certainly not any longer. And it's also, I think, important that the highly processed foods and the palatability and the accessibility and the low cost, right? We're not talking about eliminating pie and pastries. I think sometimes people think, I'll never have a muffin again. I'll never have a chocolate croissant. That's not really what we're talking about. We're not talking about a homemade cake. We're not talking about cupcakes. We're talking about things that are easily purchased at low cost, unpackaged, eaten in transit. What we're doing, I realize, is painting this picture of a little bit of the past, the recent past. But what you do so beautifully is you're really orienting us where we are now. And that the fact that we need more science, but we know an awful lot, and there's so much that we can do. And these 6 pillars of diet, exercise, sleep, avoiding excessive substance abuse or use or abuse, stress mitigation, relationships, and purpose, which center back on mitochondrial health. Could we talk about some of the other things that we can do for mitochondrial health, things we can take? These days, we're hearing a lot about creatine. What are the data on creatine and mitochondrial function or brain function? I'm not familiar with these data. I should be.
So creatine is a molecule that is foundational to energy transformation in cells. So creatine goes into the mitochondria, and there it gets combined with ATP to become phosphocreatine. and then it leaves the mitochondrion and goes to places in the cell where energy is needed, like a synapse or a ribosome that's trying to make some new proteins or something else. It goes to places in the cell where energy is needed, and it can combine with ADP to be converted back into ATP. So it's basically a phosphate shuttle. Creatine is a phosphate shuttle that is foundational to energy metabolism. It is foundational to mitochondrial function. Our bodies can produce creatine on its own as long as we have the essential vitamins and nutrients that make it up. And there are several of those. Or we can consume creatine. Creatine is found only in animal-based products, animal-sourced foods. It is not found in plant-sourced foods. So what we know is that because creatine is found in large quantities in the brain, so we can actually measure it using mass spec kind of scans. And we know that there's a range. Some people have low levels of creatine and some people have higher levels of creatine. People who consume less animal-sourced foods, like vegans and vegetarians, on average tend to have lower levels of creatine in their brain and muscles and other tissues. People with neuropsychiatric disorders, schizophrenia, Alzheimer's disease, depression, have been found to have lower levels of creatine than people who do not have those disorders. So we have reason to believe that creatine, from studies like that there is an association, meaning a correlation, between low levels of creatine and brain disorders that we call neurological or psychiatric disorders. So the next logical question from a scientist should be, well, if we supplement with creatine, can that improve symptoms of neuropsychiatric disorders? And we do have evidence to support that. Not huge randomized controlled trials in tens of thousands of people, because again, that would require government funding, because creatine is off patent. Nobody's going to make a lot of money from doing a creatine study because anybody can sell creatine. Anybody can make it and market it. It's off patent. So, but we do have randomized controlled trial data with creatine showing that it can improve symptoms of major depression. It can augment antidepressants. It can improve symptoms of bipolar disorder. It can improve symptoms of neurodegenerative disorders like cognition in Alzheimer's disease or mild cognitive impairment. But again, the studies are on the smaller side. They're not super robust quality. But unless the government steps up, unless the NIH steps up and funds a large, well-done, well-controlled, randomized controlled trial of creatine versus placebo for any of these conditions, the skeptics and the hardcore scientists are always going to say, well, we don't have good quality data. Well, we're never going to have good quality data because there's no product. That's where we're at as a field.
Do you recommend it to your patients?
Not right away. There's more research coming out, and there's more reason to believe that maybe I should be recommending it to patients more often than I currently do. It certainly lines up with a metabolic kind of mitochondrial, improve metabolic health, improve brain health simultaneously. It lines up perfectly with that.
Mm-hmm.
And I just want to remind people, before you focus on what to take, focus on what you should be doing with your lifestyle.
Mm-hmm.
What is your diet, nutrition? Are you getting adequate sleep? Are you getting some bright light in the morning? Do you have relationships and purpose in life? Are you overusing harmful substances? Because I want to be the first to say, if you're not doing those things, creatine doesn't stand a chance in hell of helping your health. It just does not stand a chance to improve your health. There is no supplement that you can take that will undo the damage that a harmful lifestyle will have on you and your health. And the reality is the statistics are abysmal. I mean, 1/3 of American adults are not getting adequate sleep. 60% of the foods that Americans are consuming are ultra-processed foods. You know, the real money is not in the question, what should I take? The real money is in what should I do? How can I change my life and my lifestyle to improve my health? And so I just want to drill that home for people, for better or worse.
I first learned about methylene blue from owning fish tanks. You clean fish tanks with them, or it's a thing you use. Now there's a lot of interest in methylene blue ever since a video of Robert Kennedy putting methylene blue in his water on a plane kind of went viral. Methylene blue has been around a very long time. What are your thoughts on it? What does it do? Is it going to help mitochondria? Is it for everybody? I don't take it.
I don't take it either, and I've not used it in any patients so far, but I'm very interested in possibly starting to use it in controlled ways in patients who clearly need something more. We're doing all of the right things. We're doing the lifestyle things. We're doing ketogenic interventions or other things, and they still are not well. There's still room for improvement. So methylene blue, as you said, has been around for a long time. It's relatively cheap as a fish tank cleaner. Methylene blue, fascinatingly, is primarily, exclusively a mitochondrial agent. So it is an electron acceptor and donor. So that is what methylene blue does. It can accept electrons and it can donate electrons. So it's an electron shuttle, if you will. And how does that relate to mitochondria? Mitochondria, as they are producing ATP, electrons are flowing down the electron transport chain. And that is what results in the production of ATP. If it gets shuttled through the uncoupling protein, it results in heat production. And when electrons flow out of that system, when they leak out of that system, it creates reactive oxygen species, which again are very harmful to both mitochondria and cells. So if you have dysfunctional mitochondria that don't seem to be able to contain the electrons appropriately, electrons are leaking out. So these would be mitochondria that are producing more reactive oxygen species than they should. Does that ever happen in biology? 100%. We've got decades of evidence that aging, neurodegeneration, even obesity, type 2 diabetes, and a wide range of neuropsychiatric disorders are associated with that process, the increased levels of reactive oxygen species, often referred to as oxidative stress. So we got decades of evidence strongly supporting that. Can methylene blue play a role in that? Absolutely, because methylene blue can come in and take some of these wayward electrons and prevent them from creating reactive oxygen species, which might help calm things down. One of the challenges with methylene blue, as we discussed before, you can have too little and too much. Same with methylene blue. You can have too little and too much. You don't want to accept too many electrons. These electrons need to be flowing to the places they should be flowing. As opposed to oxidative stress, the polar opposite of that is called reductive stress. And that too has been found in people with schizophrenia and bipolar disorder and some other disorders. So it's really about dysregulated kind of balance between oxidative and reductive stress. And methylene blue, if you take it in overdose, could become a reductive stressor. So you don't want too much, but so we do have pilot trials, again, small, not super well done pilot trials in a wide range of neuropsychiatric disorders. Depression, bipolar disorder, schizophrenia, Alzheimer's disease, others. Many of them suggesting a benefit.
Do you know what the dosage range
I don't.
is?
Yeah, I don't off the
either.
top of my head.
Yeah, because methylene blue, as I understand, has some MAO activity. The can adjust some of the enzymes that in turn adjust levels of serotonin, which is why I haven't taken it. I've just been cautious about. I don't really want to boost my serotonin. There's this recent study out of a lab at Stanford showing that the rewarding properties of various things, as we know, increase dopamine in anticipation of a reward, but also important, it seems, these are mouse studies, but serotonin drops as dopamine goes up, and that drop in serotonin is at least as important as the increase in dopamine for the reinforcing properties of certain behaviors and substances. And I'm very reluctant to tamper with anything that would raise serotonin, because in these studies or these experiments, I should say, increasing serotonin offset some of the rewarding aspects of otherwise rewarding things. So I want things that are rewarding to feel rewarding. And so this difference between dopamine and serotonin seems pretty vital. I mean, that's not to say I'm like terrified of anything that increases serotonin, but to do it pharmacologically just seems a little sketchy, given I don't have a clinical need that I'm, at least not that I'm aware of.
No, well, and that's actually one of the warnings with methylene blue, is that if taken in too high of a dose, you can actually get serotonin syndrome.
Could you explain what serotonin syndrome is?
So serotonin syndrome is just like really excessive deluge of serotonin in the system. More often than not, it's completely unrecognized.
Really?
It gets mistaken for psychiatric symptoms. So people can have anxiety, they can have panic. In extreme cases, you can get nausea, you can get fevers, you can get, in extreme cases, it can be fatal. So it's a serious thing, but more often than not, it gets dismissed because serotonin syndrome is most commonly experienced by people taking SSRIs. And by definition, they are psychiatric patients or they have a mental health condition. And so when they come in and say, I'm feeling nauseous, I feel anxious, I feel jittery, I don't feel right, they get written off more often than not.
Or given more medication, perhaps.
Yeah, let's say increase your dose. Let's increase your dose or whatever.
Oh, no.
So it's actually really tragic. I mean, one woman actually reached out to me who, after learning about my work, reading my book, she talked to her psychiatrist, tapered off all her meds, and it became clear that she probably had serotonin syndrome for a long time.
Wow.
To both her and her psychiatrist.
So the meds were causing the problem.
And the meds were causing the problem, and nobody really recognized it.
Goodness gracious.
Again, so it's so anyway, methylene blue can cause serotonin syndrome. So I think if people want to consider using it, I would, number one, make sure you get a very reputable source of it. Make sure you're consuming it in a way that makes sense. I mean, it can stain your teeth blue and all sorts of stuff. So
it makes your urine blue, your tongue blue.
But people will do IV infusions of methylene blue.
Whoa.
So yeah, no, I've seen people kind of hooked up to IVs with a bag of methylene blue.
Do they turn blue?
And they I hope not.
Smurf thing.
But it is a medically approved treatment. And I think it can be done in safe ways. Again, it's off patent nobody's going to stand to make any money off of doing large, well-designed trials of methylene blue. But I'm really interested in it as it has these properties. In addition to just being this electron acceptor and donor, there's some evidence that it may improve mitochondrial biogenesis, that it has anti-inflammatory effects, and that it can do other things that may be beneficial.
Interesting. Very interesting, in fact. Before moving on to some more clinical questions, we've been going deep into the science and some public health thoughts and reflections and ideas. There's a supplement called Urolithin A that people seem really excited about for improving mitochondrial function. I'm not super familiar with the literature, but coenzyme Q12, Urolithin A, we're starting to hear more about these sorts of things sold over the counter. Do you have any thoughts on those?
There's a company, Timeline, that puts out this product, and to their credit, they have actually done some pretty well-designed, robust, randomized controlled trials of Urolithin A. They've primarily focused on muscle health and aging. And so they actually have reasonably good data published in reasonably good journals, documenting that Urolithin A, when given to elderly people over 55, 65, that it can improve muscle mass and performance within, I think, like 8 weeks. And that has overarching metabolic benefits that have, in terms of biomarkers that have been associated with slowing of the aging process. So Urolithin A, I think, is definitely a supplement among all of the supplements that should be considered if people are looking for something to take. I'm going to repeat myself. Before you take Urolithin A, I've said this to the chief scientific officer of the company when I was talking with him about this, and I said, but that diet and exercise are much more. He said, yeah, of course. Like,
harder to sell.
People have to do
Right.
the diet and exercise and everything else,
Right.
but then this could give them an advantage. And I don't deny that at all. I think it may very well give people an advantage. And again, the way that I think about it, it's not that diet and exercise are going to cure everybody, because they won't cure everybody. Some people are really ill. And the way that I think about that is that their mitochondria, their metabolic processes are really disrupted. They are severely dysregulated. And that a quote unquote healthy diet and good exercise and good sleep and good relationships are a phenomenal prevention strategy. For some people, they can be a phenomenal treatment strategy, but I think on average, that applies to people with mild to moderate mental health or metabolic health conditions. That once people get into the severe category, severe heart failure, severe mental health condition like schizophrenia, bipolar disorder, crippling depression, my sense is just a clean diet and good sleep and good exercise is not going to be sufficient. And then we do need to start thinking about, can we use this supplement or this methylene blue infusion or even neurostimulation, which can stimulate mitochondria and stimulate neuroplasticity.
Things like transcranial magnetic stimulation.
Yes.
Which is done non-invasively, right?
It is non-invasive. And so can we use those types of strategies to try to improve someone's mental health? And we've got plenty of evidence that, especially with TMS, that it can be very helpful for some people, but again, is not a panacea. None of these things are a panacea. And although I just said that, none of these things are a panacea. So if you're, one of the biggest criticisms I get is, Dr. Palmer, you have not given me the recipe to cure my crippling X disorder. And it's like, well, I'm trying to teach you the strategies and the science so that you can put together your own treatment plan. I am not here to sell any one thing as this is the panacea to cure all mental illness. The ketogenic diet can be life-changing, life-saving. It can be nothing short of miraculous for some people, but it is not a panacea. I've seen people do ketogenic diets and not get cured, not get remission. And so I'm always looking for what else can we do? How else can we use this model to further enhance mitochondrial function, metabolic health? And I think the reason I'm getting traction is because when you come back to it, we just keep coming back to these like pillars of common sense.
Right.
Like,
for the most part, yeah.
Like diet might actually make a difference to your brain health.
I don't think it's just Americans. I think our species needs to run up against the guardrails at the edge of the cliff 6 times and sadly see a good number of people go over to their demise before we go, wait a second. We need to think about how fast we're taking these turns. We need to pull back. I mean, there's something weird about our species that we love to develop technology and then find the destructive aspects of those technology, then pull back. And a lot of our, it's like 2 steps forward, 1 step back type evolution. It seems inherent to Homo sapiens. Forgive me for getting so macroscopic here, but when you look through, there's a wonderful book, The Prince of Medicine. There's a history of medicine, Galen, and like it starts there and all the way forward. And you read like the Emperor of All Maladies about cancer, and you just realize like we're stumbling forward and making miraculous progress, and at the same time we are seemingly deliberately overlooking a lot of the stuff that's just obvious. It's like the old advice, as we exit this conversation about supplements, the old advice that if you just eat a balanced diet, you're good, doesn't work anymore. I noticed that because quote unquote balanced diet, first of all, no one can agree on that. And people get caught up in the vegetarian versus carnivore debates, which are really like, or vegan versus carnivore, which are really at the extremes. So we've lost our bearings. We're kind of like true north is so clear what true north is. It's mostly non-processed, minimally processed foods, getting adequate quality protein. You could do that vegetarian. You could do that with some animal-based products if you choose. It's doing that for 90% or 80% of one's nutrition. It's exercise. We know what forms it. Like all the information's there, as you're pointing out. But somehow we're just going to have to keep putting it back in our faces, or see enough unfortunate stuff that we go, wait a second, like this is time for a course correction. But hey, that's what we're trying to do here, right?
Absolutely.
And we have colleagues to do it as well. And I'll just throw in, as long as we're editorializing a lot today, I think in the last 5 years, the discourse around public health, from the mental health side, from the cardiology side, from the cancer side, from the launch, has really transformed in no small part thanks to social media and podcasts. So things are evolving.
Thank you, Dr. Huberman.
Oh, well, and thank you. And thank you. Vitamin deficiencies and mental health. It almost sounds like we're headed deeper into supplements, and we might touch on that. But a few years ago, I went to a McKnight meeting and somebody presented some proteomics data where they were sequencing spinal fluid from depressed patients and finding that certain depressed patients had deficiencies in certain vitamins that could easily be replaced through supplementation. And lo and behold, their depressions were, in these particular patients, were being cured, literally reversed, going into remission by virtue of taking the appropriate vitamins. But the issue was they had to use spinal taps. So it was not in order to know what these patients needed, but it was really striking. I thought, goodness, we're talking about B vitamins and depression. So could you tell us about B12 and other B vitamins and methylation and folate. There's a little cluster of topics here that I think is super interesting and that people really should know about vis-a-vis depression and other CNS challenges.
Before I get into the complex part of the story, let me just start with basics. So, and this relates to nutrition, that a lot of these basic vitamins and minerals, like vitamin B12, folate, and iron. I'll just stop there. B12, folate, and iron. These are all essential to mitochondrial function. They play a role in numerous enzymes and other cellular reactions outside of mitochondria, but they are all central to mitochondrial function. And so if you are deficient in these vitamins, your mitochondria will not function properly. So it's at least, it doesn't prove the mitochondrial theory of neuropsychiatric disorders, but it's consistent with the mitochondrial theory. And the reality is a lot of Americans are, a lot of different populations within America, and then certainly in other countries, can be highly deficient in some of these. So iron, there's a study in JAMA just last year, 40% of females aged 12 to 21 in the United States are iron deficient.
Wow.
It really depends on the definition of iron deficient, but their overarching conclusion, based on what they thought was a reasonable definition, that the journal JAMA went ahead and published, was 40% of girls and young women, 12. So this is menstruation, obviously. It's menstruation. They are losing blood. They are losing blood, and they are not consuming enough iron, or there's something wrong with the way they're processing iron. So let me just stick with that. And what does that have to do with neuropsychiatric disorders? Well, boys and girls pre-puberty have the same rates of mental illness. If anything, boys are maybe a little more because they're more likely to have autism and they're more likely to be diagnosed with ADHD. So, but for the most part, we'll say like depression and anxiety, exact same rates. Puberty hits and girls just skyrocket. The rates of mental illness skyrocket in girls. Now, are there psychological and social causes of that? Yes, we can talk about you're becoming an attractive sexual mate, and maybe people are, being mean to you, or people are, making you uncomfortable, or you are becoming a victim of sexual trauma. So do those things happen? Of course, those things are happening. Could that contribute to depression and anxiety? Of course, that could contribute to depression and anxiety. Again, it's not either or. So yes, let's stay with the psychological and social causes, but let's also go into the biological causes. If these girls and women are now iron deficient, that affects their brain function. It affects their whole body health. Most people don't think of that as a metabolic problem, but I do. These girls and women can be thin. They can be absolutely beautiful and thin and iron deficient. And that means they've got a metabolic mitochondrial problem that could be affecting their brain. And that could be playing a role in their depression, anxiety, their, eating disorder, or whatever else they've got. Vitamin B12, folate, we know that low levels of those vitamins are associated with all sorts of neuropsychiatric disorders. B12 deficiency, for example, is very common among vegetarians and vegans. In India, for example, where most people are vegetarian or vegan, 50% of their population is B12 deficient.
Whoa. What are some food sources of B12? Is
animal source
red meat, basically.
Animal source foods, again, eggs, red meat, other types of meat. Yep, you need animal source foods for the most part. Or if you're going to be a vegan or vegetarian, please take appropriate supplementation. You can get this in a vitamin, but please make sure you're doing it correctly, and maybe get your levels measured every now and then, at least once a year, your annual physical. Make sure that your doctor knows I'm vegan. Please do a full assessment of vitamin and nutrient levels for me, because I am at a high risk. So B12 is impacted by other medications, B12 absorption. And interestingly, oral contraceptives can reduce absorption of or impair absorption of vitamin B12.
Interesting.
Metformin can impair absorption of vitamin B12. So just picture a woman who's overweight, who's following a vegetarian or vegan diet, who's also on metformin for her diabetes, who's also on birth control just because, she's at very high risk of being B12 deficient. And what does B12 deficiency do in terms of neuropsychiatric disorders? Everything. It has been associated with higher rates of depression, anxiety, psychosis, bipolar symptoms, but people can be hallucinating and delusional from B12 deficiency. And the challenge with B12 deficiency is that the neurological damage can become permanent. So if this is not recognized and identified early enough, people can be permanently injured. So that's the simple story. Some people just aren't consuming enough, or they're taking metformin, or they're taking oral contraceptives or whatever. They're menstruating and they haven't really figured out an appropriate diet to compensate for the loss of blood. So all of those things can interfere with vitamin absorption or whatever, and can result in neuropsychiatric symptoms. Unfortunately, this story gets a lot more complicated. So we've long known that there's an autoimmune form of vitamin B12 deficiency called pernicious anemia, in which antibodies to something called intrinsic factor prevent vitamin B12 from being absorbed in the digestive tract. So you could be eating all the meat in the world, you can't absorb it, and you can become B12 deficient. That autoimmune disorder increases with age. So you could have been living a happy, healthy life, and then at age 65, you develop pernicious anemia. You can no longer absorb B12. And this is actually one of the treatable forms of dementia that we know of. The cardinal symptoms look like dementia. And the only way to help these people is if some astute healthcare clinician measures a B12 level, identifies and recognizes the problem, and then does further testing for pernicious anemia, this autoimmune form of B12 deficiency, and then you correct it. And the treatment is vitamin B12 injections. Taking a pill won't work because you can't absorb it, so you just got to inject people with vitamin B12. And it can restore everything.
For most people, will a B12 oral supplement work? Like a methylate B12 capsule?
As long as they don't have this autoimmune form, yes.
Okay.
It'll be fine. And again, if you're eating lots of meat, you may not need any supplement at all. So over the last year, there have been a couple of publications that have just come out that have now recognized a brand new form of autoimmune B12 deficiency. And it targets a protein called CD320, which transports vitamin B12 across the blood-brain barrier. The researchers essentially identified this in people who are having pretty severe neuropsychiatric symptoms. So symptoms of either neurological disorders or other kinds of disorders, but mostly focusing on neurology because it's neurologists who have been doing all this work. When they first identified this antibody, they took blood from these people's veins, just like you would if you were going into a doctor for blood draw. The B12 levels are normal. Everything's normal in the periphery because the person may be consuming enough B12 and it may be getting absorbed. Fine. So they're not anemic. They show no signs of B12 deficiency. But when the researchers tested their cerebrospinal fluid, they had almost no B12 in their central nervous system.
So that requires a spinal tap, right? This is not.
In order to diagnose it, it required a spinal tap, and they ended up treating some of these people with immunosuppressive agents to reduce this autoimmune condition and high-dose vitamin B12. And some of the people had reversal of symptoms, meaning their neuropsychiatric symptoms went away. The research is still in preliminary stages, but the researchers have looked at how common is this? Because at first glance, it sounds like, well, that's just a really rare condition. That can't be relevant to human health. They sampled just a general healthy control, and about 6% of those people had this antibody.
Wow, it's really high.
They then sampled people with neuropsychiatric lupus. So these are people who have an autoimmune disorder already, lupus, and they have neuropsychiatric symptoms. 20% of them had this antibody. And then they just recently, this is unpublished data, but they have looked at people who have a demyelinating condition of unknown etiology, and about 50% of them had this 50%.
So this is like an MS-like condition.
Had this antibody.
And what's the solution? B12.
The reason this is of interest to me, and we're hoping to do some research on this in patients with psychiatric disorders, is because there is a treatment. Immune suppressive kind of treatments to either reduce this autoimmune condition and or high dose vitamin B12 injections. So you want to flood their system with vitamin B12 so that some of it can get across the blood-brain barrier.
And again, oral B12 won't work in this case, right?
Oral B12 may very well work in that case. But I would actually, in these situations, what we know is that these people's brains are being damaged from severe B12 deficiency. So I would probably just go for the definitive massive injection and try to rescue those brain cells.
This is very interesting. I think people should get their B12 levels measured. It's standard blood test, right?
It is. Unfortunately, for this new autoimmune central B12 deficiency, they're working on a commercial test, but you can't get this blood test right now.
Okay.
So
perhaps to come.
Stay tuned. But I guess the point of it is this, that I think for the majority of people, 60 to 80% of people who are suffering from neuropsychiatric disorders, I actually think using interventions that are easily available today will help them heal and recover. I really believe that. I stand nothing. I don't get any money from lifestyle interventions. I don't get a commission for everybody who does a ketogenic diet.
In theory, you'd have fewer patients to treat. In theory, you lose money because you have fewer patients to treat.
I will lose money by getting people better, and then they move on and don't need me anymore. I honestly believe that, but I also believe there will be 20%, maybe up to 40% who have severe disorders for whom those strategies just won't work. And so I'm really interested in, well, what else could it be? And this is just one of many examples of what else it could be. They could have an autoimmune form of central B12 deficiency. And why does that matter? Because we can test for that. And if they have that, we can treat it. There's a clear, unequivocal treatment. And, at the end of the day, I think one of the biggest themes of my work is that right now, in the mental health field, we assign these diagnostic labels to people. And for many of them, they become life sentences. You have schizophrenia. That's a lifetime sentence. It's probably never going to get better. You certainly always have to take medicines for the rest of your life. You have bipolar disorder. It's for life. You have chronic depression. Sorry, we just don't know how to treat it. depression should go away, but it's not going away for you. We don't know what to do. Sorry. So sorry. I know that, on the surface, it may sound like, well, those are just rare people, Chris. They're not rare people. Hundreds of millions of people on our planet are given these life sentences. And we assume that we now know the cause. The cause is you have schizophrenia. That's the cause. And in fact, schizophrenia is only a label of symptoms. Schizophrenia means a person who has chronic psychotic symptoms of unknown etiology. Because if we know the etiology, you don't call them schizophrenic anymore. You say they have vitamin B12 deficiency and psychosis. Or you say they have an autoimmune disorder like lupus and psychosis. And why is that so important? Because there's a treatment for these other things other than just antipsychotic medicines. And what I really hope and implore our field will do is we will come into the 21st century and begin to recognize that there is a cause of schizophrenia. There is a cause of bipolar symptoms. There is a cause for chronic depression, and that we will begin to look for those causes and we will begin to treat those causes, as opposed to just putting people on antipsychotics or antidepressants or mood stabilizers and telling them, well, we're really sorry. We know these medicines don't cure your illness. We know these are not disease-modifying treatments. We're really sorry. We can't do better. You're just going to have to suffer for life. Like, we can do better.
And I applaud your efforts to bring about that change. I mean, I think people realizing that often, not always, but often mitochondrial dysfunction is at the heart of these things is critical. Speaking of which, I have to ask, and feel free to pass on this question if you like, but I've become very interested in vaccine biology and the debate about vaccines, about the adjuvants that are used to deliver the vaccines. Obviously, there's a very contentious topic. I just want to know, without being, I'm not trying to be provocative here, is there any evidence that vaccines or the adjuvants for vaccines or anything about vaccines and their delivery can disrupt mitochondrial function? So often we think that it's like the vaccine having a specific effect on what the vaccine was designed to target that could potentially cause side effects or something like that. That's what many of the theories hold. But given the key role of mitochondria in all aspects of brain functioning, and given that some people are convinced, I'm not saying I believe this, but are convinced that vaccines are tied to these mental health challenges or to autism, let's be direct about this. Is there any evidence that vaccines of any kind can disrupt mitochondrial function or support mitochondrial function for that matter?
It is a contentious.
Maybe it's a different episode.
No. And I'm definitely going to answer it, but I'm going to give a long-winded answer if that's okay, because I want to give credible information.
Yeah, that's the only information we're interested in.
And I don't want to come down on one side that vaccines are 100% safe. There's no question about it. Or yes, vaccines cause autism, and that's why we've got skyrocketing rates of autism. Because I don't think either of those extreme positions is true. So I want to first back up and just ask a slightly different question. Is there any evidence that high levels of inflammation impair mitochondrial function? The answer to that is unequivocally yes. High levels of inflammation, inflammatory cytokines like TNF-alpha, interleukin-6, and others impair mitochondrial function. We know that. It is clear and unequivocal. And there are physiological reasons for it. The organism has to adapt. So when you have the flu, do you have neuropsychiatric symptoms? Yes, you do. You're going to feel exhausted. You're going to be less risk-taking. You are not going to want to reproduce, more than likely. You're going to completely lose your libido. Completely lose it. Like zero interest. And what are you going to want to do? You're going to want to hide in bed and pull the covers over you and just retreat from the world for safety. Those are all effects on your mood, your motivation, rewarding behaviors, all sorts of things. The inflammation, the infection is doing that to you. And we know that it's inflammation because this happens with cancer. It happens with treatments that cause inflammation. If we give treatments that cause high levels of inflammation, people experience these symptoms acutely. If we give interferon, for example, which can be a treatment for some disorders, people will acutely develop all of these symptoms. So we know that interferon itself will produce all of these neuropsychiatric symptoms. We also know from basic cell biology, interferon interferes with mitochondrial function. We know that. It is unequivocal. Now let's go to autism. Is there any evidence that inflammation can lead to autism? We have decades of evidence for this. We know that over the course of the last century, as there were kind of outbreaks of bacterial or viral infections in the population, we saw higher rates of neuropsychiatric, neurodevelopmental disorders in the offspring of the pregnant women. So we've long known that, and that evidence is pretty well established.
For instance, forgive me, but the one that I'm aware of is that flu in pregnant mothers at the first to second trimester transition is correlated with statistically higher incidence of schizophrenia in the offspring. Do I have that right?
That's correct.
Okay.
But then there was a rubella outbreak that resulted in much higher rates of autism in the offspring. I think that was in the 1960s. And now we have really decades of animal models. So they take mice and they inject them with lipopolysaccharide, which causes an inflammatory reaction. And when they do this to pregnant mice, the mice that are born to those women, those female mice, are at much higher risk for showing signs or symptoms of what looks like a neurodevelopmental disorder. It's different diagnosing or whatever a neurodevelopmental condition in a mouse. Is it 100%? No, it's just we increase the risk. So if you inject a pregnant mouse with lipopolysaccharide, can that mouse still have a normal appearing mouse? Yes, but the probability that the offspring will have a neurodevelopmental symptoms of a neurodevelopmental condition increase. That is where so much of the autism research has been focused, is trying to understand this, trying to understand what is happening with inflammation, how does that impact neurodevelopment? We know that. So now back to the question that you posed. Is there any possibility that vaccines could contribute to that process? Do vaccines increase inflammation? I think the answer to that is yes. Is there variation in the inflammatory response between different people? I think the answer to that is yes. Can some people have a hyper-exaggerated inflammatory response in response to a vaccine? I think the answer to that is yes. In that condition, so in that rare, less common condition where somebody is having a hyper-exaggerated inflammatory response to a vaccination, could that impact neurodevelopment? The science right now says yes. We have no reason to think it wouldn't. There's one case of a young child who already had an existing mitochondrial disorder. It was already known. She got vaccines, and I think within days or weeks of getting the vaccinations, she developed profound neurodevelopmental symptoms. That case won a lawsuit. It went to court, it was tried in court, and she won. And the court ruled that the vaccine did, in fact, contribute to this girl's neurodevelopmental condition. Now, they assumed it was because she had a pre-existing mitochondrial disorder. And I would support that. It lines up perfectly with what I've been talking about all along, that people who have vulnerabilities with mitochondria or metabolism, you can only absorb so many hits. And when you get that final hit that tips kind of the balance to impact neurodevelopment, you can get that. Now, coming back to the bigger question, so should people get vaccinated or not? We do have reasonably good evidence that unvaccinated people are more likely to develop autism than vaccinated people.
Is that right?
The problem with that study is that it's a retrospective cohort epidemiological study. And the biggest critique that I have of that type of research is that the researchers decide what they control for and what they don't control for. But the existing research right now, as published and as designed, suggests that if you don't get a vaccine, you're more likely to develop autism than if you do get a vaccine. And how would I understand that? I just talked about it. Infections themselves can cause neurodevelopmental disorders. So if a child gets measles, they're not only at risk of dying of measles, they're also at risk of impacting their mitochondrial function and developing a neurodevelopmental disorder as a result of getting a severe infection.
Assuming there's choice, there's a risk-benefit analysis. Do you want the potential inflammation from the vaccine or lack of inflammation? You run the gamble. It's hard to predict who's going to have a big inflammatory response and who's not. Although I'm thinking in the back of my mind about these lifestyle factors, even though it's a young child or an adolescent in some cases, but young children typically, there are things that you can do to bolster the health of that kid going into a vaccine if you're choosing to vaccinate your kids, right? Like proper sleep, proper nutrition, proper everything. You wouldn't want them even slightly sleep deprived because that would increase the risk of inflammation, right? I mean, these things compound, as I understand it. So, you know, I think what most all parents really want is a sense of control over what are inevitably a mixture of controllable and uncontrollable factors. And this is what I hear when I really listen to this debate about vaccines. I hear my science colleagues inevitably saying, okay, the Wakefield data were BS, et cetera, like, no, there's no possibility. And then I hear parents who are having kids, whose kids are due for vaccines, and they're like, I don't know what to do. They're terrified. And these are smart people, and they don't know what to believe anymore. That's the challenge.
I mean, the science that I just laid out is true. It's clear. And again, we've got decades of research to support most of what I've just said, all of what I've just said, I think. If you understand the biology, when a child begins to show symptoms of a neurodevelopmental disorder, instead of assigning a label, this is autism, it's a life sentence, good luck, we should be intervening. And what could we do to intervene? What you just said in terms of prevention strategies, absolutely. let's make sure that even before you're going to the doctor, even before you're exposing yourself to any of these vaccines, that you're healthy. Why? Because we want you to be healthy. Why wouldn't you want to be healthy? So let's just be healthy. But I would actually go much further and say as soon as a child begins to show signs or symptoms, especially when it's an abrupt change, when they were developing in a neurotypical way and then all of a sudden they got an infection or they got a vaccine or something happened and now they are falling off the trajectory. And that's what we hear from these parents who are saying, no, this is real. That's why they believe vaccines cause it. Do I think it was just the vaccine on its own? I suspect a lot of them have had other hits. They probably had other vulnerabilities going into that vaccination. And that the vaccination, if we even entertain the possibility that that vaccine did contribute to their autism, I'm doubtful that it was the sole only cause. I'm doubtful that it was the sole cause. But regardless, once the kid starts showing signs or symptoms, we should be doing a full workup. We should be looking for vitamin and nutrient deficiencies. We should be looking for this central B12 deficiency. Did the vaccine somehow cause an autoimmune reaction to CD320 so that now this kid has central B12 deficiency, and that is why this kid is falling off the chart? Should we entertain a ketogenic diet for this child? I would say yes. We should. That should be on the table of options. We might want to put this child on a ketogenic diet. Does that ever happen? It happens all the time in kids with epilepsy. So why not do it for neurodevelopmental conditions? But again, it's not just keto diet is going to save the day and we don't have to think about central B12 deficiency or any of these other things. Like, let's put it all together. And especially with AI now, we can do this. This is a solvable puzzle. It is a complex puzzle, no doubt. But it is a solvable puzzle, and we should start to solve it. But right now, the state of the field is that we assign a label autism, and we tell the parents to just prepare for a disabled child. Just prepare yourself to take care of a disabled child for life. We're really sorry. We don't have anything more to offer. We can do some ABA training. We can do some basic, we'll try to teach them some social skills. The real outcome data on that is pretty bad. If your brain's not working right, it's hard to teach people how to do the skills that the brain is designed to do. And that's the challenge, is that it's all well and good to recognize a problem, but now we need to come up with effective treatments. And we know that a lot of the, people talk about early intervention with autism as though early intervention is going to save the day. I don't mean to bash the people doing that work. Let's do anything we can. It might help a little, but when you look at the outcome data, it's not helping much. And when you look at the statistics of the prevalence of autism, it's going through the roof. So those strategies are just not working. They're not working for prevention. They're not working to improve long-term outcomes. We have a lot of work to do. So
I appreciate the thoroughness of your answer. I can promise you that anything we put out about that will include the full context. We're not.
People will take the soundbite, and
well, if they do, I'm gonna get rabid by posting the preamble, because it's very important that people hear the full context. It's and I really appreciate you embracing that topic with the depth and rigor and sensitivity also that you do, because I don't think we can duck this vaccine question anymore. I never thought in my lifetime that vaccines would be a thing. It's like when I was a kid, everyone got the polio vaccine, the measles vaccine, and we kind of went about our way. I do understand the number of vaccines that kids are getting now, like the vaccine schedule has expanded. I've been kind of thrown into the middle of this, as different guests have come on this podcast who've said they do get the flu vaccine, others who say they don't. And, gosh, if ever there was a separator besides Democrat versus Republican, it's this vaccine thing. It's really like the separator. It's so closely tied to believes in science, doesn't believe in science. Like those are the stereotypes, right? Or suspicious of science, NIH and CDC, or believes in science, NIH and the CDC wholeheartedly. Like the divide is very stark, and this needs to stop. Like the divide needs to stop. We need to start filling in with answers, and I think there's soon to be a scientific exploration of the relationship between vaccines and autism. I read this someplace on X, which means could be true. But I think that's the idea, and I think some people were kind of upset that resources were going to be devoted to this because they felt like it was a done deal, and then others are very excited because they feel like, hey, listen, if you don't think there's a link, then here's an opportunity to establish that with real rigor. And I think everyone's just really interested in the studies being done properly. I think more data is always great.
I don't disagree. I've actually talked to some former NIMH directors about this and some other leading people in this field. And there's no doubt that this topic has been brought up multiple times at the NIH. So there's this interagency coordinating committee on autism among all of the NIH kind of centers and institutes that's existed for decades. They have looked into this issue. I've talked to some autism advocates who've said, like, I was hoping that vaccines might be the cause. Like, I was really hoping to see that vaccines are the cause, because that would then give us a cause, and it would lead us to interventions to make vaccines safer or whatever. And she said, but it's just not there. It's just not there. And this former NIMH director that I spoke with, it's just not there. Chris, it's not there. We looked high and low. Again, I'm not sure that everybody looked with the same degree of scrutiny. Again, the study that I saw looked at people who are unvaccinated by choice. So these are rebellious people who are defying state laws, who are risking not getting their children into schools because they're not getting vaccinations. That's the cohort of unvaccinated people. And then they're comparing them to the cohort of vaccinated people. And they only controlled for like 2 or 3 variables. They did not control for obesity. They didn't control for diabetes. And we know that obesity and diabetes play a role in risk for autism. And we know that people who have existing health conditions might actually be more likely to be worried about vaccines and then not get vaccines. Perfectly happy, healthy, thriving people usually just go along with the status quo. They usually don't refuse vaccines. So people who are refusing vaccines probably had some pre-existing health condition. They didn't control for that. Did that pre-existing health condition increase risk for autism? Probably.
If there's an inflammation link, then yes.
Probably. I mean, you look at any pre-existing health condition, and does it increase risk for other health conditions? Usually the answer is yes. So we know that women with obesity, much more likely, twice as likely to have an autistic child.
Is that right?
Yeah. Meta-analysis, over 3 million people. Women with obesity have double the risk of having an autistic child. Have rates of obesity been skyrocketing in our population? The answer is yes. Are pregnant women also in that camp of obese women? Yes. Well, that accounts for a doubling of autism. Same deal with diabetes. Women who have diabetes, twice as likely to have autistic children as women who don't have diabetes. When you put the two together, obese and diabetic, quadruple the rate of autism in the offspring.
What about dad? There are these theories about the statistically significant increases in rates of autism for offspring of men who are 50 or older. My read of the data is that it's still a very small increase. It's not like the kind of increases you're describing here for diabetes.
It is. So men with obesity, twice as likely to have an autistic child as men who are not obese.
Yeah, which is something like 25 times greater than the increase due to age of the male. So this is so important because people hear, older sperm equals higher probability of autism, but yes, still a very low probability of autism compared to dad is obese, but in his 20s or 30s.
Yes. And so, a lot of people are hyper-focused on vaccines cause autism, and they come back to rates of autism are skyrocketing. There has to be a reason. Well, I agree. Rates of autism are skyrocketing. I agree there does have to be a reason. Maybe we're missing the elephant in the room. Rates of metabolic poor health are skyrocketing in our population. Rates of obesity and diabetes are skyrocketing, but rates of poor metabolic health. So metabolic syndrome has 5 biomarkers. Abdominal obesity, blood pressure, glucose, high levels of glucose, and then high triglycerides and low HDL cholesterol. Those are the 5 biomarkers of metabolic syndrome. Only 7% of Americans are healthy in all 5 biomarkers.
Yikes.
Only 7%. Poor metabolic health influences neurodevelopment in offspring. We know that. So we see skyrocketing rates of autism. It's not just autism. We see skyrocketing rates of ADHD as well, simultaneously. And everybody's scratching their heads trying to figure out, where's all this autism coming from? Where's all this ADHD coming from? Well, look around, people. As the metabolic health of the United States population declines, we are going to see more neurodevelopmental disorders.
Such a critical message, but also reassuring in the sense that we can do something about it.
We can.
Because what you're talking about is metabolic dysfunction, mitochondrial dysfunction of the parents, right? So, trying to control the behavior of still unborn or yet to be conceived children is pretty tough to do, and yet anyone thinking of conceiving should really pay close attention to their metabolic health is clearly the message. I think obesity becomes a little bit of a critical factor, yet a distractor. That wasn't meant to rhyme. For when we hear metabolic health, I think a number of people hearing this will say, well, I'm not overweight, so my mitochondria are probably healthy. But what you listed off included high triglycerides, you said blood pressure, which, there's some thin people or, non-apparently obese people. I say apparently obese because a lot of people are carrying a higher body fat percentage than they realize, even though they're not, taking up a lot of space. So I think, it's not always, and low HDL. So sometimes, we're shocked to see like, oh, this person is like apparently healthy, but has, low HDL and has got their ApoB is through the roof and they're not well. But just because they're not obese doesn't mean they're metabolically healthy, correct?
That is absolutely correct. And I go back to some of our prior conversation. So a 14-year-old girl who is severely iron deficient is metabolically unhealthy. Why? Because her mitochondria can't function properly without iron. She can be thin. She can otherwise look like a healthy, attractive girl, but she can be metabolically unhealthy because she doesn't have all of the essential vitamins and nutrients that she needs to have properly functioning mitochondria and metabolism. And Why would that matter? It matters because she might develop an anxiety disorder, or she might develop depression, or she might develop symptoms of an eating disorder. And then we're all scratching our heads, giving those labels. Oh, you've got depression, you've got anxiety, you need Prozac, and maybe she really needs iron.
Right. I mean, what I realized, and this was really where I wanted to bring us to, is a question for you. I have an idea, but let's also pose the question as an idea, and feel free to bat it down. I'm beginning to think that in order to get out of this health rut that we're in, that clearly relates to mitochondrial dysfunction, and at the same time, there are tools, the lifestyle tools that you described. There are supplements, and maybe methylene blue will be advantageous, and methylate B12 perhaps, but certainly the lifestyle factors. Most people, again, when they hear metabolic health, they just think, okay, metabolism, obesity, thinness or fatness, and it sort of becomes a gravitational pull towards that. Do you think it's possible to create a metric? I don't want to say BMI as an example because that's controversial for some people, but is it possible to create a metric of all-around metabolic health that would be incentivized so that people can live better lives, their offspring can be healthier as well, and we can unburden the healthcare system and potentially avoid millions and millions of people having these so-called incurable mental health disorders, in air quotes?
What you're describing is kind of, in my mind, a really important next step. And the great news is that there are several research groups that I know of that are working on exactly that. One is a commercial company. I'm not going to name any names, but one is a commercial company that has a product of a series of biomarkers, blood biomarkers, that they believe represent ultimately mitochondrial dysfunction, all of the different cellular pathways that can result in mitochondrial dysfunction and or can reflect mitochondrial dysfunction. And they believe that their test might be able to predict the development of autism, that every child at age 1 should get this blood biomarker, and it will tell us who's at high risk of developing a neurodevelopmental disorder. The test itself doesn't tell us what's wrong. It just tells us something's wrong. And then the clinicians need to go to work and try to figure out what is going on, what is causing this metabolic mitochondrial dysregulation, so that we could potentially intervene. I've talked with one of the leading mitochondrial researchers really in the world. He's got a set of 20 biomarkers that he believes represent mitochondrial dysfunction broadly. And then there's another research group that is actually narrowed it down to just 5 different biomarkers in men and 5 slightly different, there's some overlap, but slight differences in women. And those 5 biomarkers alone were able to distinguish people with chronic severe suicidal depression from healthy controls with over 90% sensitivity and specificity.
Wow.
So I think that is one of the directions we need to go, is we need to establish tests with all of these groups. I want to just state clearly and plainly, because one of the common questions I get is, what's the blood test I can get for my mitochondrial health? There isn't one. That's the answer. There is not one. There are lots of different biomarkers that can suggest dysregulation of metabolism and mitochondrial function. And again, these 3 research groups are all working on it. In order to get those 5 biomarkers for men and women, I think they measured 400 different biomarkers. So we need to make sure that that gets replicated, that it's, prospectively, it can identify people. I'm less concerned about kind of the incentivizing and let's give insurance discounts and other things. I actually think the majority of human beings that I know authentically want to be healthy. And they really want to have healthy children. They will do anything to have healthy children. So I don't think we necessarily need to come up with some incentives right now. I think if we develop evidence-based tools that prospective parents can use to assess their own metabolic mitochondrial health, and maybe more importantly, assess their prospective children's health. And then we pair that with evidence-based strategies to help them improve their metabolic health so that it will improve the outcomes for those children. I mean, that's the holy grail. What I just said probably represents decades of research. The sooner we get started, the better. And some of it's already underway, as I've mentioned. So it's not like we start from ground zero. People have been on this trail for a while. But it is going to require a concerted effort. It's going to require massive NIH funding to support that type of research. We have a new administration that is talking about massive disruption in the way things are done. They're talking about massive changes at the NIH. I'm really hoping and praying that we're going to see that type of research, as opposed to the current model of research, which focuses on, well, here's your diagnosis, schizophrenia or hypertension, and what new pills can we develop to treat this condition, or how can we understand this condition? I think we have enough evidence to be able to really start with to be able to really aggressively pursue more effective treatment and prevention strategies.
Fantastic. What role do you see yourself in going forward? I mean, clearly public education about these issues related to metabolic and mitochondrial health is a wonderful home for you. In addition to all your clinical work and everything else you're doing you're clearly very passionate about it. If I may ask, do you have plans to get involved in helping the new NIH, new Health and Human Services folks, steer in the right direction?
I am more than happy to serve as a consultant if asked, and I have had some conversations with a wide range of people. So I'm more than happy to do my part. I think for the immediate future, honestly, I'm focused on some of these lines of research through McLean Hospital and Harvard Medical School. I'm really aggressively working on setting up a healthcare system practice to start where we will treat people with these severe chronic mental health conditions that I started a wait list about a year ago, and I have over 5,300 people on my waiting list.
Wow.
I can't treat 5,300 people, but I have the privilege of a lot of brilliant clinicians are reaching out, wanting to work with me. What I'm hoping to do is to put into practice, into real world practice, everything that we've talked about and more with real human beings to demonstrate this really does work. It really does work. And I've been doing this work as a solo clinician for 30 years now. And I welcome the opportunity to begin to develop protocols and processes and use artificial intelligence to really try to create algorithms. If we can do that, then yeah, we hold the potential to help millions, if not billions of people. And the theory is great. And I'm really a big fan of the theory. It continues to line up. New evidence, since I've published the book, new evidence has come out just completely supporting it. And if anything, bolstering it. Putting it into actual clinical practice is really where the rubber meets the road. And as we've just talked about, there are so many things we can do for people who are suffering today. And I'm probably, it's not even probably, I'm most excited about that. I'm most excited about training other clinicians and demonstrating for the world that this really works, that people can get better from severe treatment-resistant mental illnesses.
Fantastic. Well, I and everyone else are super grateful for your real enthusiasm and like clear devotion to that last statement. And, I'll finish today's discussion with where we started, which is to say thank you for being such a pioneer for this clearly new direction for mental health and for bridging the gap between mental health and physical health and clarifying for all of us today what people mean when they say metabolic health. We really have to think about mitochondria, what they do, the many, many roles they play in cells and are everywhere in the body, and the paths to improving mitochondrial health, lifestyle, supplement, in some cases drug-based, and the preventative care that we can take, especially for people that are thinking of conceiving children, to get their metabolic health right, but also of children, regardless of age. And also for your public health work. I mean, you really put yourself out there. You were willing to embrace this vaccine question and did it with incredible care to all sides, and at the same time staying really close to the data in hand and offering new questions. So that's just as emblematic of everything you do, Chris. And it's such a pleasure and an honor to have you back again. And if people want to reach you, we'll provide portals for that. I know there's a lot of outreach toward you. I really also appreciate seeing you on social media, on X and on Instagram. It is really important that people hear from you. And then what's lovely also is that as new studies come out that agree or disagree with some of the things that have been said today, you're always one to put those out there and address considerations and get people excited, but appropriately excited, or cautious, but appropriately cautious. So thanks for everything you're doing. Far too much to list again right now. Hope to have you back again because the progress is happening so rapidly. In the meantime, thanks for this incredible voyage and education for me and everyone listening. You're doing God's work. Thank you.
Thank you, Andrew. And thank you for doing everything you're doing. You're also doing God's work. And I know that, what you do is not always easy. And trying to give actual practical protocols, so to speak, is really important. And you're probably doing more for the mental health field. I don't know. I'm struggling to think of who's doing more for the mental health field and the mental health of millions of people around the world than you right now. I'm hard pressed to think of someone.
It's a collective effort with folks like you and the people that come on here, so I consider you a colleague and a comrade, for lack of a better word. We had a Russian on here recently, so comrade in that effort. But yeah, thanks. I think I know how much you care and I care too. So thanks for those words.